Boa.
Estou, Luís Alexandre, consegue ouvir-me? Estou, Luís Alexandre, consegue-me ouvir? Eu não tenho a câmera ligada.
Câmara é mesmo dele, não é?
Tá.
Doutor, bom dia.
Perché? Come è?
Posso estar com alguém?
É um estudante ou um
Não
docente?
sei, não sei ideia.
José Luís Alexandre, consegue ouvir-me? Não, está com o chat.
Então, sim, bom dia. Vocês não conseguem
Bom dia.
ouvir? Bom dia.
Professor, consegue ouvir-me bem? Eu consigo ouvi-lo.
Eu, perfeitamente. É porque eu deixei, entretanto, deixei de vos ouvir e tive dúvida se havia algum problema aí de som, mas não. Está tudo ok. Tá.
Obrigadíssimo,
Obrigado.
professor.
Tá,
Obrigado. Até
obrigado.
já.
Até já.
Luís, ai,
Devia ser connosco.
não, mas não sei quer já connosco? Não venham, tira-se já. Sim, que eu lá normalmente tenho um filho, não é? Mas não foi. Não venham, e a Sónia e o Luís.
Já uma foto.
Fica para o.
Ou já uma foto.
Então, se calhar, Ana Cláudia, é assim, porque eu costumo ser os representantes das 4 unidades de investigação. Aí eu quero fazer um pouco de superfície. Qual é essa parte para baixo? Mas não é igual para o Luís, que eu vou mandar a nota própria.
Porque é exatamente vertical, não é? Então, muito bom.
Está fixe. É que isto ainda o evento não começou, nós estamos a publicitar.
Agora é o que já finaram? Já ficou bom?
Não. É, mas foi exatamente, obviamente, só estes mas públicos, tens acesso, mandem para mim que eu mando. É que eu posso pedir só alguns testemunhos, eu tenho acesso ao.
Pode ser assim fortes. Ah, isso não é como
Eu sei Carlos, não, mas José Carlos não costuma ser ele, ou o Pedro, nós temos.
igualdade de género, isto é perfeito. 2-2, né?
Se nós a minha, se calhar, mando para.
Depois manda também para mim. Está aqui a coisa a jogar. Já pode no relatório.
É muito lento.
Vou ver se.
Só, já foi começando para já. Ana Cláudia e Kátia, não sei se a vossa apresentação já estará comigo. Se calhar é melhor pôr, porque eu sei que vocês me mandaram, mas eu não coloquei, não trouxe na minha pena, estou com o computador avariado, não é emprestado. Portanto, as apresentações da manhã já estão todas aqui colocadas. Acho que aqui assim. Não, acho que aqui, obrigada, Daniel. Antes do coffee break é que temos mais urgência em. Não é como é que eu faço aqui escape. Escape deve ser aqui. É quando nós vamos chegar lá. Isto é tudo diferente. Ai, Daniel, escape, não faz um escape.
Está em modo partilha, tem que interromper,
Interromper a partilha,
tem que
certo.
interromper a partilha.
Está bem,
Tem que interromper a partilha.
certo. E depois vai ao escape.
O tempo que estamos.
Ai, eu ando à procura daquela ali. Onde se calhar vou assim, minimizo, para encontrar as coisas mais depressa.
Tu,
Olha, diga, sempre aqui. E também está este, se calhar foi posto. Mas esta vez eu já não sei se eu já pus uma pança.
Aqui.
Apresentações. Publicações. Desculpa. Tem Cadê? Versão 3. Não, agora eu acho que não é acontecer muita coisa. Eu acho que nada por dizer é esquisito.
Deixa eu ver o que alguém falou. Vamos distribuir as apresentações. Isto, ok. Quer partilhar outra vez já a apresentação ou vão começar?
É melhor para partilhar.
É?
Sim. Eu quero depois. Tem ou já, Alex?
Desculpe.
Não?
Não é melhor já está. Peraí. Já está aqui.
Está tranquilo. Usar o mouse.
Eu uso só os reflexos, eu nem gosto de estar Daniel estar ali a sugerir um.
Obrigada.
Desculpe, queres um momento?
Não, vamos começar agora.
Queres ver agora?
É novinho.
Vamos dar início, então?
Levanta agora. É melhor. Vocês.
Desfios.
Nós já vamos a começar com
Para vocês.
fazerem as nossas carinhas agora.
Acho que é melhor, sinceramente. É melhor.
De cara já lá mais serena.
Acho que sim. Lá vai ter luz.
Isto é quando querem forçar o zoom, não é? Porque senão automaticamente vai fazendo.
Sim. Ok.
Onde é que está a câmara?
Está ali. Pode sorrir para aquela. É número 1. Não, obrigada. Obrigada.
Podemos dar início, então?
Podemos, sim, senhor.
Então, se calhar. Bom dia a todos, bem-vindo a este workshop que pretende ser o encerramento do projeto SNAP. É um projeto que envolve 3 unidades de investigação da Universidade do Porto, o CMUP, a qual eu pertenço, o Centro de Matemática, a UP Green, a que pertence a professora Susana, o SISTEC, a que pertence o professor António Pedro Aguiar, e o ICT, o Instituto de Ciências da Terra, a que pertence a professora Ana Cláudia Teodoro. Este projeto teve o financiamento do Norte 2020, a quem agradecemos todo o apoio que prestaram. Ele basicamente está dividido em 2 linhas de investigação, linha 1 e linha 2. A linha 1 envolve a UP Green e o ICT.
Green no Porto, já.
Green no Porto, sim, engano sempre, está sempre a corrigir. A Green no Porto. E a linha 2 engloba o CMUP e o SISTEC. Passo então a palavra à Susana, que vai dizer algumas palavras sobre os objetivos da linha 1. Depois eu direi algumas palavras sobre os objetivos a que nos propusemos na linha 2 e depois segue-se os oradores.
Muito bem. Bom dia a todos, muito obrigada pela vossa presença. É um privilégio para nós estarmos a concluir um projeto, que este projeto foi um projeto de 2 anos, portanto são projetos que acabam por, nós estamos a iniciar e depois já estamos a acabar, não é? 2 anos, todos nós sabemos que é relativamente pouco tempo para desenvolver estes projetos que acabam por ser bastante ambiciosos. Foi um projeto que tem uma tipologia diferente das tipologias a que estamos habituados. No fundo, é um projeto que pretende, cujo financiamento tinha mesmo por base o objetivo de pôr unidades de investigação da Universidade do Porto, portanto, não era para externos, portanto, os únicos parceiros tinham que ser unidades de investigação da Universidade do Porto, tinha que ter no mínimo 2, portanto, no nosso caso conseguimos agregar 4, não é? Portanto, foi uma mais-valia, e também achamos que foi muito interessante estarmos a pôr aqui pessoas que normalmente não trabalham nesta área, e os meus colegas também, que certamente foi muito desafiante para eles, da engenharia, da matemática, e sobre este guarda-chuva, um bocadinho das culturas protegidas, nomeadamente do vertical farming, portanto as culturas nós podemos chamar fábricas de plantas, já vamos ter uma discussão sobre isso, não é? Fábricas de plantas ou horticultura vertical, que são culturas feitas em ambientes altamente controlados, e daí também a importância da programação, da modelação, de utilizar a imagem para poder apoiar o produtor na tomada de decisão nestes sistemas, que são sistemas muito atípicos de produção de alimentos, não é? E, portanto, nós, como vocês viram, temos um programa até bastante intenso, temos esta primeira sessão mais dirigida à componente tecnológica, portanto, em que as apresentações são praticamente dos colegas da matemática e da engenharia, exatamente, e depois da parte, depois do coffee break, vamos ter então as sessões mais relacionadas com a produção, com as mais propriamente ditas, com as fábricas de plantas, está bem? Portanto, a primeira será assim mais tecnológica, mais matemática, e depois a outra com uma vertente mais agronómica e mais de produção. Vou tentar aqui partilhar, porque este computador, deixem-me ver, vou fazer aqui partilhar a tela, só um momento. Vai. É que este escape não está. Oh, Daniel, este escape não está realmente a funcionar. É que eu queria ir agora queria ir à pastinha onde estão as apresentações.
Tem que terminar o compartilhamento.
Está bem, era o que me tinha dito. Compartilhamento, não é? Pronto, e agora, para minimizar. Ele agora já vai. Agora vou minimizar normal, certo?
Sim.
Mas ainda continua este.
Porque este aqui agora.
Este se calhar foi
Agora é que pode fazer o escape. Agora esqueci isso.
Sim.
Snap.
Não, está ali, está ali. Open session, pronto. Então, naquele enter, posso fazer aqui? Não.
Eu entro.
Qual é? Aqui mesmo. Obrigada.
Agora não esqueça de partilhar por casa.
Agora,
Share screen.
clica
aí.
Aqui.
Share.
Vou partilhar. Temos sempre que fazer isto, não é?
Quantas pessoas estão de fala neste momento?
Neste momento estão 3. Neste momento.
E agora lança aqui a
Sim.
apresentação.
Muito bem.
Se quiser, depois pode esconder isto aqui ou ocultar.
A barrinha.
Ocultar.
Mas ela aparece. Ao voltar. Eu acho que já nos estão a ouvir, não é? Eu acho que estamos com som, não está? Nós estamos com Silvia, não sei se quiser. Pode ficar na mesma. Só mais para eu mexer melhor. Muito bem. Pronto. Então, a Research Line 1. Agora a pena não funciona. A Research Line 1, fazendo só aqui um pequeno enquadramento, é aquele tópico que já toda a gente sabe, não é? No fundo, a população mundial está a aumentar, mas o enfoque aqui, quando se está a trabalhar com fábricas de plantas, não é só a população mundial que está a aumentar, é que 68% da população em 2050 vai viver em ambiente urbano, portanto vai viver nas zonas urbano e periurbano, portanto nas grandes cidades. Isto traz-nos alguns problemas e traz-nos também algumas oportunidades. Portanto, o vertical farming é realmente um sistema de produção emergente, permite que as culturas sejam feitas ao longo de todo o ano, portanto não está dependente das condições climáticas, desculpem lá. Isto hoje, eu acho que o PowerPoint está a seguir sozinho. Pronto, portanto tem a vantagem dos ciclos de produção acabarem por ser mais reduzidos, porque no fundo vamos dar às plantas todas as condições ótimas de crescimento, elas em vez de demorarem mais semanas a serem produzidas, acabam por encurtar e portanto no final de um ano conseguimos introduzir muitos mais ciclos de cultivo, acaba por ser utilizada, está calculado para certas culturas que se pode produzir com até menos 70% de utilização de água. Não há uma perda então de áreas, no fundo podemos deixar, porque às vezes fala-se, mas então produzir nestes sistemas parecem meios artificiais, mas pode-se deixar no fundo a terra arável, a chamada terra arável, pode ficar disponível para outras culturas, ou até para a biodiversidade e para outras utilizações, e portanto também pode permitir, está também comprovado que leva a alimentos mais nutritivos, com a utilização de cerca de 50% menos de fertilizantes, que são sistemas que fazem reutilização, recirculação das soluções nutritivas, tanto com a água como os nutrientes, e como estamos a crescer as plantas em condições ótimas, completamente isoladas do meio ambiente exterior, acaba por não ser necessário utilizar pesticidas ou herbicidas, ok? Portanto, isto é um bocadinho um enquadramento muito geral àquilo que são as fábricas de plantas. Esta é uma imagem de uma fábrica de plantas, que é uma das maiores fábricas de plantas da Europa, que eu estive a visitar recentemente. Portanto, aqui vocês conseguem ver realmente o sistema de produção são 14 prateleiras todas empilhadas, com lâmpadas LED, e isto são produzidas este é o produto final, ok? Portanto, nós na linha 1, o nosso objetivo da linha 1 ela engloba estes 5 work packages, tem o primeiro e o segundo work package mais ligado então aos sistemas produtivos propriamente ditos. Temos então 2 estudos de caso, foi a utilização de plantas microgreens, portanto são os microgreens, depois vamos explicar o que é que elas são. São então estes microgreens, e depois temos também como uma planta medicinal que é Catarantes roseus, que é uma planta que também vamos ter uma apresentação sobre ela e vamos ver então, ela é utilizada, tem fins medicinais, e o objetivo é utilizar as fábricas de plantas, nomeadamente a utilização de radiação ultravioleta, para induzir a produção de compostos de metabolitos secundários. Depois temos aqui esta linha, este work package foi desenvolvido pelo ICT, portanto, em que o objetivo era utilizar também umas abordagens tecnológicas para ir acompanhando as culturas e tomar algumas decisões de uma forma mais precoce, para identificar algum stress, no caso de existir, etc. Portanto, também vamos ter os colegas do ICT a apresentar isto. Temos o Work Package 4 do Consumer Perception portanto, a percepção do consumidor e a valorização dos produtos. Temos o professor Luís Cunha e a Mariana como os principais, as pessoas que estiveram por trás, e eu também acompanhar um bocadinho por trás deste desenvolvimento desta linha, também bastante interessante. E por último, claro, temos também um work package ligado à parte da disseminação, e hoje estamos a fazer um encerramento precisamente com essa vertente. E portanto, esta é a perspectiva geral do que é que se pretendia na Research Line 1, está bem? Depois o meu colega vai então apresentar o que é que se fazia na
Podia pôr,
Diga?
pôr a minha apresentação.
Pois, eu faço Skype e não sai. Já o cá não saía. Não sei. Não. Força.
Se calhar já pôr aí.
Deixa-me ver aqui. Já lá.
Ah, e a seguir?
Esta?
Não.
Isto é touchscreen.
Tem as minhas iniciais. Se calhar é melhor outro lado.
Cuidado, é essa melhor não tocar aqui porque...
SG, ali. Por cima, é que está assim.
Esta?
Sim.
Pronto. Ah, sim. Só que ainda está neste. Bem, não viu ao bocado como é que isto se fazia? É que este computador é completamente...
Pois é diferente do meu. Interromper
Sim, isso tínhamos feito
compartilhamento.
o compartilhamento, sim.
E depois era aberto o PDF. Foi o que eu percebi.
Nós tentamos fazer isso, já está aberto. É este? Sim.
É.
Pronto. Agora o problema é que temos que
Não tenho
voltar.
que full screen, se calhar, não.
Eu tinha pedido para ter aqui algum apoio, porque eu realmente admiti logo que isto não é o meu ponto forte.
Pois, eu também não.
Não, e ali embaixo está o símbolo do PowerPoint. Fazer o close.
Luís, pode estar aqui mais, por favor.
Você deve ter que pôr assim full screen, se calhar, não?
Como é que está a apresentação?
A apresentação é esta.
Mas está. Posso fechar esta?
Sim, fecha, se calhar é isso que vai fazer com
E esta? Esta também não é esta também.
É esta que está aqui, esse já. Isso.
Já está. Se forem full screen.
Ainda tem que abrir. Não abriu. Está. Ok.
Esta é a minha coisa fechada, vamos ver como é que está esse botão de colocar.
Eu acho que não vi a cena.
Não é um PDF, mesmo aquele PDF.
É esse, cadê?
Este.
É esse.
Ah, ok. Eu estava à procura de um
Mas temos
PowerPoint.
que fazer partilha de ecrã.
Certo.
É o PDF.
E é compartilhar tela.
Se for assim todas as transações, não vamos já.
E agora? Aí está bem?
Já está.
É isso por aí, o screen, o PDF.
Já diz assim, é? Para fechar a ler.
Não é visualizar. Visualizar. 2 menos para a esquerda.
Mas podem chegar aqui, se calhar.
Não,
É que está.
já se consegue.
Just press apply.
F5.
Eu estava a fazer o Afonso. Pronto. Agora está.
Se tivermos isto em todas as passagens, não vamos conseguir cumprir o programa.
Bem, a segunda linha de investigação deste projeto, a RL2, portanto, era dedicada à modelação, simulação e controle ótimo de gestão de sistemas de produção agrária. Havia duas grandes áreas. Havia uma área dedicada a técnicas de modelação e simulação para gerar uma fábrica digital, portanto, à partida seria um software que fazia a mímica de uma unidade de produção e isto deveria, em princípio, funcionar e, em certo sentido, conseguiu-se, embora, digamos, não desejável, deveria, digamos, ter inputs da linha RL1 para analisar séries temporais associadas a crescimento de plantas. Teria também, e teve uma outra área, que era para desenvolver algoritmos, e nós vamos apresentar alguns aqui nestas apresentações, para fazer estimação estimação ótima de certos parâmetros. Portanto, o principal objetivo, portanto, desenvolver modelos matemáticos e de engenharia para fazer gestão gestão e controle de sistemas, digamos, puxar o estado de conhecimento atual para novas áreas, portanto, permitir o ajuste de produção digamos, também vai haver uma produção nesse sentido, digamos, ao perfil das encomendas. Portanto, há um pacote de encomendas, como é que nós vamos, digamos, fazer a gestão da fábrica de modo a satisfazer essas encomendas. Pronto, e basicamente é isso que eu queria dizer-vos e acho que podemos passar agora às apresentações. Tá? Portanto, a primeira apresentação de hoje vai ser feita pelo Gil. O Gil era um dos investigadores que estava na origem do projeto e será Tracking Vortices and Circulations using Advect Passive Particles. Portanto, isto é um trabalho realizado pelo Gil, com a minha colaboração e também com a colaboração do Marco Martins Afonso, que está ali presente. Sim, sim. Eu acho que prefiro sentar-me ali para ver. Como é que eu tiro isto?
Agora não sei como é que eu partilho.
Tens de partilhar primeiro.
Zoom, isso. Um bocadinho. Tela. E agora compartilho.
It's not.
Sendo que não seleciona.
Osama, you take the responsibility to. So Osama will be our
Supporting our technical
Yeah.
work.
yes. It's super. Thank you. Because you know all this.
O ponto era isto, não é?
É isso.
É
Isso. Gil, não, o de cima é
É o
para.
ponteiro.
É mesmo ponteiro. Se pressionar durante
Sim, sim,
algum
sim.
tempo, assim as pessoas conseguem ver online, está bem?
Sim, sim,
Isto é
sim.
para frente.
O meio é para avançar e o resto é para recuar.
It's in Portuguese.
Oh,
Oh, it's that one. Okay.
Okay.
Okay, is it working?
Yes.
Portuguese. So I'm going to present the work that I made with with Professor Silvio Gama and Marco Martins Afonso, which is called Tracking Point Vortices and Circulation via Advected Passive Particles. And while I'm not going to talk exactly about plants or plant growth here, we know that plants don't exist in a void, and there is an environment, and we have to take care of that environment, and we might need to know some things about that environment. So that's why we did this study. This is a first study on a conceptual multi-agent model that deals with the dynamics of flows, for example, air flows or water flows that might interfere with the plant growth. The summary of this talk, I'm going to just show two examples of where the flows can affect plant growth, then talk a little bit about some basic fluid dynamics so that we understand what I'm going to talk about, pose the problem, explain the method we are proposing to solve this problem, and some results which are basically the validation of the method that we are proposing. So, for example, when we are growing plants or crops in a greenhouse, there are ventilation systems, and these cause airflows around the room, and we might need to track down the dynamics of that flow. Or, for example, if we are growing plants in a body of water, there are water currents, and we might need to know the dynamics in that water flow. So what is a point vortex? The thing that is in the title of the presentation. Mathematically, it is a singular solution of the two-dimensional inviscid vorticity equation. But for those who don't understand really what this is, it's basically a point-like entity that is characterized only by its position and its circulation. And this circulation parameter, it acts like, if we think of a point particle, it's like the mass. But here, it measures the rotation of the fluid, of the flow around the point vortex. And these point vortices, they are used to model flow dynamics in a way that it avoids that we have to solve the full Navier-Stokes equations, which are the equations for the flow dynamics, that take a lot of computational power to solve. So this is easier to solve and faster to solve. These point vortices, they interact with one another, just as we can think like masses interact with one another through gravity. And there's a system of equations for the motion of these point vortices, which are here presented in a complex formulation. The z variable is the typical x plus iy. And to solve these equations, we need to know the circulation of the vortices, this gamma here, and some initial position of the vortices themselves. But this is not easy to do in most cases in real phenomena. So that's where we go to the passive particles, which are like tracers of the velocity field, and they do not affect the flow, or they don't interact with the vortices, and there are also some equations that govern their motion, which are similar to the ones before. And these are easier to trace, so we can probably use them to solve our problem, which is how do we find the circulations and the strength, and the positions of a system of NV point vortices, when all we have available is the number of vortices in the system and the trajectory of some particles during some time period. For simplicity here, we are going to assume that our data is taken in equally spaced time increments of h. Okay, and the mathematical formulation of this problem is this. Basically, we are trying to minimize this difference, which is the ZPs are our data, what we measure from the passive particles, And the ZP tilde here are some estimates of these particle trajectories that we obtain from solving these equations. So how are we going to tackle this problem? We are going to take advantage of the fact that the circulation of the vortices themselves are constant in time, so we can divide this problem into two sub-problems. At first, we're going to find the circulations without caring where the vortices are. And then after we have a good estimation for the circulations, we are going to find the vortices themselves. The basic idea for the first part of the method, which is estimating the circulations, is that since they are constant in time, as I said, we can have different snapshots of the system at different times. For example, one snapshot at 3 a.m. and another one at 4 a.m. will give us information about the circulations, which are the same at both times, even though the vortices can be in completely different positions. And some remarks about this is that for any fixed time, the system of equations that we need to solve to find the circulations has 3 NV unknowns. And for each passive particle we have, each of them will give us 2 pieces of information because we have the position of the particle in the X and the Y direction. So that's 2 pieces of information, and we're going to need at least 3 NV over 2 particles in order to retrieve some information about the circulations of the vortices. Also, since the equations that I showed before are nonlinear and the algorithms to solve them numerically need an initial guess, we need to provide the algorithm with an initial guess for both the circulations and the positions of the vortices. And these need to be dug out from the data itself. For example, analyzing the trajectories of the particles, or even when the vortices themselves can have some type of physical manifestation, we can actually see those vortices in photographs, for example. So the idea of this first algorithm is to first estimate the velocity of the passive particles if it is needed, because sometimes in the data we also get the velocity of the passive particles. Then we provide the initial guess that I just talked about and solve a nonlinear system of equations to find the circulations and positions at some time. Then we iterate this by updating the estimates for the positions of the vortices at the next time step through the dynamical equations of the system. And we also modify the initial guesses for the circulations in order to explore the parameter space further, so that we can have a good estimate for the circulations. And then we repeat this process until our data is exhausted, and we are left with a set of values for the circulations, where we can do some statistical analysis to obtain the values of the circulations for these vortices. So now we are at the point where we have the circulations, an estimate for the circulations, and we want to find the trajectories of the vortices. And in general, there is an issue here, which is that these vortex systems exhibit chaotic dynamics if the number of vortices is 4 or more. And when we are trying to solve the differential equations for them, if we have any small error in the initial condition for solving the equation, then that error can be highly amplified, and we get a trajectory that has nothing to do with the real trajectory. So our solution for this problem was to partition the trajectories of the vortices in some parts and then reconstitute each of those parts sequentially and separately. But this gives us another question. How do we choose this partition in order that these small errors in the initial condition aren't highly amplified? Our first thought here was to use something that is called the Lyapunov exponent, which is basically a quantity that measures the rate at which 2 nearby trajectories separate from one another. This has some problems, mainly because of the second point here, which is the computation of this Lyapunov exponent is slow and heavy. And if we are in a scenario where we want to track the flow fields in real time, this is not suitable to use. There's also another problem, which is that we only have data for the particles, and the Lyapunov exponent for the system of vortices and for passive particles are different. However, in a chaotic system, they are within the same order of magnitude, And so we can probably use them to build a partition for the trajectories. However, due to the second point here, we decided to discard the Lyapunov exponents idea, and we went with autocorrelation functions, which are functions that are fast to compute, and they can be used to find a characteristic time after which the state of the system has no memory of the initial state. So this should provide a good time for us to partition the trajectories of the system. So in order to reconstitute the full vortex trajectories, we are going to reconstitute n partitions of this form, the mathematical form. I'm not going to bother much with this. And we can build n sub-problems that are akin to the original one, like this. And this is the mathematical formulation for these new sub-problems. The last one is a bit different because we are not partitioning the full time interval into n equal partitions, because the last one, where our data finishes probably a little bit earlier, because what is fixed is the time of each partition. And what we do basically is we set the cutoff for the autocorrelation function, and we compute the autocorrelation function for each of the particles that we have data for. And then we take the minimum of those characteristic times through all the particles. Then we compute the partition that we need to make, and then solve each one of those sub-problems for each partition separately and sequentially. So what we did was we simulated the system with 4 vortices and 20 passive particles. The circulations for the vortices were made 1, 2, 3, 4, just because it was some simple numbers. And we simulated this for a time period of 10 to the 5 units of time. We did this simulation very long so that we could get the Lyapunov exponent for the vortices in order to check if the autocorrelation time checks out with this Lyapunov exponent. And we found 0.028 for the Lyapunov exponent of the vortex system. We then introduced some Gaussian white noise to the data in order to simulate real data, because when we go and find real data in the environment, it will be corrupted. And then we smooth that corrupted data using a Gaussian filter, the trajectories, and we computed the particle velocities and ran the first algorithm to find the circulation. We managed to find the circulations with an error of less than 0.5%, a relative error of less than 0.5%.
1, 2, 3, 4.
1, 2, 3, 4, yes. And this is basically a box plot for the distribution of values we obtained from running the first algorithm on the circulations. They are shifted down by 1, 2, and 3 in order to have everything in the same axis, but we can see that the distribution of points in circulation is clearly aligned with the true values of the circulations. Then we ran the second algorithm, and we obtained a typical time value of about 40 units of time, which is in accordance with the value we got from the Lyapunov exponent in the simulations, because the inverse of this time gives us 0.025. It's pretty close to the Lyapunov exponent of the vortex system. We managed to recover the trajectories of the vortex system with a total relative error of around 0.44%. Then we ran again this just to check how it would recover when we didn't introduce any noise in the data. And using the uncorrupted data, with the relative error decreases to 0.08%. This is a picture of a part of the trajectories of the vortices in color, and in black, it's one passive particle that we chose that is going around the vortex in red. And this last plot illustrates well how the partitioning is working to decrease the relative error. Here we have the relative error at each time point in the simulation. And we can see that these discontinuities in the function are basically where we have partitioned the trajectory. So each time, anyway, we can see that every time the relative error starts to grow exponentially, the partitioning is working to make this relative error get to a lower value. So this is it's really working. So in conclusion, this method that was presented is a first study and it can be improved. If we use optimization techniques and algorithms that are specifically tailored for these equations and this problem, we will probably manage to increase a little bit the accuracy and the speed of the computations. We saw that it is possible to effectively recover the full vortex dynamics with a good degree of accuracy. And this opens up the possibility of studying more complex problems, for example, predicting the positions of vortices and particles in future times. This is the references, and thank you for your time. If there's any questions.
Perguntas? Eu tenho. I have. So, nice work, by the way. We already been discussing. So, first question, how sensitive is this with the initial conditions?
Very sensitive. That's one of the main issues. And the other issue that I didn't talk here is that usually we don't know the number of vortices in the system.
That was my second.
I thought so. And we are trying to, we're working to try and solve that problem of finding the initial number of vortices in order to input in this algorithm.
Yeah, I think that partition was a very nice idea.
Yes, yes, yeah.
Okay, but we can discuss after.
Okay.
Yes, otherwise, yeah.
I think the probability of having the chaotic dynamics and something like Brownian motions, it's very high because it's very.
Yes.
I don't know if this happens a lot in fluid dynamics, but there is a lot of sensitivity in
initial conditions. Yes,
initial conditions. So
that's why I focused a little bit more on saying we need to input some initial condition to the algorithm, because we need to really analyze the data before inputting that first initial condition.
Yeah, it has chaotic behavior. Yeah.
Thank you.
Thank you very much.
Thank you very much. The second speaker today is Jorge Ferreira.
Maybe check the chat, just know
If there is a question.
Yes. Mechanical fluidos. Okay. But I think somebody answered.
Ok.
Somebody answered.
O meu grande é esse. A ideia é este aqui, mas tem que ficar a pressionar o ponteiro, está bem?
Bom dia, a minha apresentação será sobre a modelação matemática do planeamento de pedidos na fábrica vertical, que vai incidir sobre a otimização e gestão de uma carteira de encomendas. Este será o outline que vou fazer. Inicialmente vou falar de um problema geral, depois vou fazer a descrição do problema, variáveis, restrições e outras hipóteses que foram feitas, e por último vou analisar um caso com duas plantas. Então o que é que pretendemos? Pretendemos otimizar uma carteira de encomendas de uma fábrica. Sabemos que esta fábrica tem uma certa colheita, a colheita pode ser constituída pelo número de plantas, eu vou indicar mais à frente. Para cada uma dessas plantas sabemos que existe uma certa configuração de crescimento. As baterias requerem uma certa temperatura, cor e uma uniforme. E cada uma dessas prateleiras terá uma configuração única. e pode ser mudada automaticamente ou manualmente. A notação que vou usar aqui está, é a notação de Santini, que posso ter, no fim vou apresentar o artigo, vou indicar o artigo. Então, para facilitar entender a notação e o que é que ela significa, eu vou dirigindo apenas ao exemplo dos parâmetros. Então temos uma fábrica, temos uma colheita, a colheita constituída por 3 plantas, morango, alface e pimenta. Queremos fazer o planeamento para um período de 100 dias e para cada uma dessas 3 plantas vamos ter um vetor procura. Neste caso, para as 3 seria um vetor uma matriz. Vamos ter ao todo 30 procuradoras, por exemplo, e podem ser indexadas de A1 até A30, mas vão ser identificadas pelo código. Vamos designar o sigma começando no edifício ou banco de sementes, tal onde vamos receber onde a pressão é armazenada e o nosso conjunto S, onde é o conjunto das prateleiras. Vamos supor, e isto é uma grande suposição, que o alface passa por 3 fases e que o morango e o pimento passam por 4 fases. Claro que isto é uma grande simplificação porque, na realidade, passa por mais fases, mas para efeitos de verificação passa por estas fases. Vamos supor ainda que o morango demora 30 dias a crescer, a alface 20 dias, o pimento 40 dias, e estas condições todas vão ser indexadas pela letra I, de 1 e 2 até I4, por exemplo, e para além disso vamos supor ainda que cada prateleira acomoda 20 paletes. Claro que assumimos 20 paletes para todas as condições, para todas as prateleiras, mas isso não é necessariamente verdade. Ou podemos visualizar este problema, em vez das prateleiras, imaginá-las em termos do tipo de prateleiras. As paletes são medidas, as prateleiras podem ter diferentes tamanhos consoante a planta que acolhem. E pronto, usamos o conjunto T e, tal como o conjunto S, também definimos o conjunto de estudantes. Como tinha dito, o número de paletes que cada prateleira acomoda depende da configuração e do tipo que ela tem. E vamos supor ainda que uma fábrica não vende morangos, pimentos, alfaces a bolso, vende em cabazes. Então, por exemplo, vamos supor que uma palete contém 25 pimentos, ou 25 pés de pimentos, ou 25 alfaces. As nossas variáveis são dois tipos. A variável X constituída por 5 índices, representa umas unidades de apelado que estão no 10º dia que chega. Prateleiras tipo T1 e que no dia T mais 1 serão movidas 42, e por último a variável Y representa o número de prateleiras tipo T, a configuração K no dia D. Este aqui é um exemplo simples de uma possível sistema de uma fábrica de plantas. Produto apenas alface. A alface, como tinha dito, passa por 3 fases. A primeira fase demora 6 dias, a segunda fase demora 12 e a última fase passa por 2. Temos aqui, por exemplo, algumas dessas condições. Nosso objetivo por uma questão de logística, é minimizar o número de alimentos. Porque é que também queremos minimizar o número de movimentos? Quando as paletes são movidas, há o risco de danificar as plantas. Então, aquilo que queremos fazer é minimizar esse risco e também a movimentação das paletes também é poder desmorada. E depois temos este fosse o objetivo e tem um aspecto assustador. Agora, as restrições. Há umas restrições de satisfação da procura, plantação, a configuração. A plantação, por exemplo, a partir do momento em que temos a carteira de encomendas, sabemos indiretamente quando é que temos que fazer a plantação. Temos ainda as restrições da capacidade e também no equilíbrio que nos permite então fazer um movimento no dia. Para todas estas para todas estas variáveis. Há certamente algumas que não fazem sentido, como por exemplo, o banco de sementes não pode receber plantas em uma fase de crescimento. O banco de sementes é apenas isso, o banco de sementes. E o armazém também não pode enviar plantas que já estejam prontas para outras prateleiras para voltar a crescer. Também, todas as paletes que estejam em dias que não sejam viáveis, que estejam, por exemplo, na primeira fase, não podem ir diretamente para o armazém, porque têm que passar pelas fases necessárias. Agora, vamos supor ainda, para o nosso caso, que a destinação para duas plantas, cebolinha e ervilhas. Isto é uma grande simplificação. A fábrica elabora durante 15 dias, o cebolinho demora 8 dias a crescer, as ervilhas demoram 10 dias, temos 16 prateleiras, 5 tipos de prateleiras. E ainda, vamos supor que cada prateleira tem uma certa configuração e apenas essa. Ou seja, a prateleira suporta no máximo 5 paletes. Então aqui estão.
Continue.
Não está possível.
It's working.
Para completar a anotação, temos aqui a barra de configuração, temos destino para cada uma delas, as configurações e os tipos de prateleiras. Vamos supor que a distribuição das prateleiras dos tipos é esta. As primeiras 3 prateleiras são do tipo T1, e por isso funciona na configuração K1, e configuração I1 e por aí adiante. O nosso fator de procuras que está a ser uma matriz, para a cebolinha, teremos 2 paletes no dia 12, 3 paletes de ervilhas para o dia 13, e esta aqui será a nossa configuração a nossa, digamos, integração e configuração de cada planta. Simplificadamente, cebolinha, configuração de crescimento é I1, I2, I2, I3, I3, I3 e 4. Então, as ervilhas teremos uma configuração semelhante, claro que com diferentes fases. Então, pretendemos então minimizar o número de movimentos. A nossa função objetiva tem este aspecto nesse estador. E o que aconteceu é que o número total de variáveis é de aproximadamente 46, 47 mil. O número de distribuições é de 55 mil a 56 mil. E o nosso sistema de execução, apesar deste número grande de restrições e variáveis, é de apenas há uns segundos no nosso computador. Eu não quis apresentar aqui a solução com as variáveis, porque senão não seria claro. Então, neste diagrama aqui temos a representação em gráfico da trajetória e aqui temos efetivamente o planeamento. Eu usei aqui as cores, algumas cores para distinguir cada fase e as prateleiras que estão em cada fase. Vamos ver que, no caso das ervilhas, estão com a cor cinzenta. Embaixo. Estão com a cor cinzenta. Apesar de começarem mais tarde, elas poderiam passar por cada uma dessas fases e uma sugestão poderia ser, mas porque é que as ervilhas e o cebolinho não podiam estar na mesma prateleira? Podia estar. Uma outra solução seria esta. E por último, o que fizemos foi usar programação linear para fazer esta simulação, para produzir ainda mais um número de variáveis. Assumimos que as prateleiras do mesmo tipo acomodam a mesma configuração e ainda para produzir ainda mais um número de variáveis, se houver mais de uma prateleiras do mesmo tipo, impedimos os movimentos de LEDs dentro do mesmo tipo. Porque elas estão no mesmo tipo, estão na mesma configuração, não vale a pena estar a mudar. Claro que, do ponto de vista logístico, isso pode não ser bom, porque se tivermos prateleiras que não estejam completamente cheias, vai ser benéfico preencher as prateleiras totalmente e depois deixar mais espaço para as que venham a si. Toda esta programação foi feita em Python, com recurso às ferramentas do pacote Piano, que de facto foram essenciais para a introdução destas variáveis e das restrições. E estou por concluir a apresentação. Obrigado pela atenção.
Aqui na minimização é só o número de movimentos, não há qualquer custo relativamente às prateleiras estarem completamente cheias.
Não é isso.
E nem só o movimento.
Isso é um movimento.
E mesmo assim, existe aquele número enorme para 2 carros.
Para duas contas, sim. Isso é. Se minimizarmos o número, temos só uma planta, mas podemos um horizonte maior, o número de variáveis também explode, literalmente. E neste caso, fizemos com aqueles dias, mas fizemos com mais dias, com mais prateleiras, e claro que isto foi uma simplificação, mas se tivéssemos as fases todas, o número de variáveis aumentaria ainda mais. Mas ainda assim, com 100 dias, também não foi tão rápido, mas ainda foi da ordem dos segundos.
Só há um movimento por dia, né? Não podes ter mais que um movimento. Sim, por isso no máximo.
Várias colheitas, não é? O moinho neste dia pode ir para a fase seguinte.
Sim, eu estou a dizer no mesmo produto.
Na prática não há muitas necessidades de circular, de estar a movimentar. É mesmo mais no momento da colheita e pode ser no momento da inspeção. As plantas durante o ciclo cultural normalmente são inspecionadas 3 vezes. E durante esses momentos da inspeção poderia ser útil porque senão tem que fazer é estar a subir nas prateleiras e alguém estar a subir. Ou então tinham que ter câmaras a nível de todas as prateleiras, mas isso era bastante confortável. É fácil de ajustar um algoritmo deste a qualquer outra espécie ou é relativamente simples?
Sim. Assim, nós contamos com duas, era para dar o exemplo com duas, com mais do que uma, mas pode ser com mais do que uma, pode ser com mais do que um. No artigo, esta estrutura é feita com mais do que até 6. Mas aquilo que é feito lá é ligeiramente diferente.
Vamos fazer mais uma vez. Okay, the next speaker is Adja Rosa Viva, Energy Efficiency Automated Remote Control, Group Light, and Decision Control.
So hello everyone, I am Hajar Busriba. I am going to present our work about energy efficient automatic remote control of grow lights in indoor precision agriculture.
I think you should.
Okay, thank you. I'm going to present a brief introduction, why smart indoor farming, IoT in agriculture, remote control, monitoring and data collection, our case study, which is remote control of grow lights in indoor farming, result discussion, and the final conclusion. Indoor farming refers to growing crops on vertically stacked layers in controlled indoor environments. The growth environment in indoor farms is controlled and technology is used to support decision making. The monitoring and control tasks can be performed remotely using IoT technologies. So why smart indoor farming? There are many advantages and opportunities that are associated with indoor farming. So the indoor environmental conditions, nutrients, and irrigation doses are controlled. The crop is protected from bad weather, climate change, diseases, and pests. Allow stable all year round production. Monitor plant growth and health conditions in real time. Maximize yield and product quality. Reduce the production cost and labor. Reduce environmental impacts and increase resource use efficiency. The IoT in agriculture is based on physical structure, which contains some sensors and devices, such as temperature and light sensor, some actuator control like HVAC system and LED lights, and microcontroller that are used to perform in data acquisition, either in remotely or locally. And the data processing, like data mining and image video processing, and the data analytics, which helps to monitor and control via a microcontroller the different production systems. So the IoT network structure is based on a set of IoT devices that are interconnected wirelessly. So they send data to the router via upward traffic to the router or to a local server. Then the server will treat the information and will send it back to the node in a downward traffic. So we have the upward traffic, which the data is the sensor measurement, and we have the downward traffic where the data is the controlled values. As we all know, light is a crucial factor for plant growth and development. It represents the source of energy of the plant, and the plant requirements include light quality, which refers to the specific wavelength of light received by the plant, light intensity, which refers to the photon flux density, PFD, in the photosynthetically active radiation received by the plant, and the light duration, which refers to the amount of time which the plants are exposed to light per day. So in our case study, we considered 3 types of light: the photosynthetically active radiation, the far red light, and the ultraviolet light, as the picture depicts here. Now, in our case, we considered an indoor farming with multiple growth rooms. With different product and different light requirements. So each grow room is equipped with a microcontroller which measures the sensor data from the sensors that are placed in the canopy level of the plant. And when the microcontroller measures the data, it will send it wirelessly to a master device in a control room where the data are processed and stored, and the control values are computed. Then it will send it back. The control values are sent back via wireless communication to the microcontroller in each growing room. And the microcontroller will apply the received values by adjusting the light intensity via PWM signal. So in the server, a learning algorithm minimizing the following objective function is used to compute the DUT cycle, theta, needed to obtain the desired light intensity based on sensor measurements. So we have this So we have this method, which is based on theta, and we have the L, which is the actual measures, and we have the L hat, which is the desired value. And then we apply the Newton method, which is used iteratively update the values of theta. We have the J prime, which is the first derivative of the J, and the second derivative J second. And we have the learning rate, which rates and updates each time the value. So after implementation, we got the following results. Control values sent from server to client, measurement values sent from the client server. So despite the noisy measurements, we remark that the control values still converge to the desired value, even the rooms are different. And concerning the far-red light and UV treatment, we see that even they sense different data for data transfer from different sensors or each growing chamber. We see that all the control values converged also to the desired value with the same duration, and yes, and there are temporary changes, of course. Concerning the network performance, we evaluated the three packet loss ratio and the energy consumption by varying the routing methods and by varying the number of nodes and time. As we can see that the energy is low, but here when the number of growing chamber, which are nodes, increases, so the energy and consumption, even the packet loss ratio increases as well. And we tried to evaluate our work in a large scale. We chose 60 growth chamber, and we obtained the following results. Our control method still gave a good result with the same conversions to the desired value. Final conclusion, we propose the remote control architecture to control grow lights in indoor farming. So it ensures the good management of the light conditions. Its scalability to large-scale plant factories has been proven. And despite the bad network quality that occurs only in extreme communication conditions, the control architecture was still able to ensure proper management of the lights. Improving the energy efficiency of the production process while ensuring optimal growth conditions for the plant is still possible. Okay. Thank you.
Questions, please?
Sorry. So in that numbers, how many chambers were you simulating?
We variated from 10 grow chambers until 16 grow chambers. Yeah, 60. Yeah.
60.
Yeah.
So it's all using the same network?
Yeah, it's the network that variates. So you have a network of 10 IoT devices.
Yes.
It becomes 60 IoT devices. Each device is controlling a growth chamber. So we tested the.
We present the node by the growth chambers.
And then you implement this using the software that emulates.
Yes,
the,
that emulates the real
the real
values,
condition.
yes, the standard value standard.
So 60 is a large scale plant factory. So we tested this for a large scale.
Thank you very much.
We have.
So it's you now. The next speaker.
We have comments. We have questions.
I have questions.
I don't know if this one is for Adju.
Yes.
Is it possible to extend the model of this? I'm lost now.
It's gone.
It's gone. Yes.
No, it's
Oh, sorry. Is it possible to extend the model of optimization to estimate the reduction on carbon emission?
It's only a parameter.
This is a tool to manage the data in precision agriculture or in indoor farming, and it can be implemented inside, connected to a decision support system in the server that minimizes carbon emission or cost or anything. So in this case, we used some methods to minimize the energy, but you can use other objective functions to minimize other things, but this depends on the values that you apply in the plant factory.
And depends on the objective function desired.
Yeah, you design a decision support system in the server that minimizes the
Carbon.
Is there another question? That minimizes whatever criteria you desire and computes control values that adjust the growing conditions according to your desire, according to what you are minimizing. I hope this answers the question. So this is a way to manage the data transfer. Remote control. You control from a remote place. Okay, there is no message.
Okay, so the next speaker is Osam, a mechanistic competition model for country bacterial cancer disease dynamics.
So, hello, and I'm Osama. I am going to present part concerning modeling of plant growth. And in this case, we have a model of competition on a resource between a kiwi fruit plant and a bacteria that infects the plant and causes a bacterial canker disease in kiwi fruit. This work is within the SNAP project. And to motivate the
Press any key in the keyboard. Okay.
to motivate the development of this model, I will start by introducing precision agriculture. In agriculture, data to make agriculture a precise production system, data is collected using field sensors, remote sensors, like cameras, LiDAR, satellite data, weather forecast data. This data is analyzed by filtering, cleaning, statistics, using feature extraction, pattern recognition, and is used to develop a decision support system using methods like mathematical modeling, control, machine learning, IA, and in this case, we are studying the case of mathematical modeling in decision support systems. And this decision support system is used to precisely apply the computed decision using robotics and automation like drones, smart actuators. They are used to apply the control values computed in this decision support system. Sorry. Okay, and this has many benefits. Amongst them, we have enhanced decision-making, provide real-time monitoring and optimizing management practices, improve crop yields, health, nutritional quality, increase resource use efficiency, reduce production costs and labor, reducing weather conditions impacts, increasing sustainability by minimizing chemical runoff and conserving resources. And I'm going to present an introduction to how to make a virtual twin of plants, which is a mathematical or computational model. So a virtual twin is a virtual representation or simulation of a real plant in a digital environment. And it's a computational model that can replicate plant behavior and its physical characteristics and processes of the production and everything. So it uses data or knowledge from, something is wrong with this remote control. So it uses data or knowledge from genetics, growth patterns, environmental conditions, management practices applied, and the time and the growth stage. And we use data from here, or our knowledge from here, to make or develop a virtual twin of the plant. And this virtual twin of the plant is used to make predictions and compute optimized decisions. So it is a powerful tool for plant scientists, researchers, and farmers in precision agriculture. It allows to perform virtual experiments. It allows to perform virtual experiments and simulations, testing different management strategies, reduce interactions with the actual plants, reduce on-field experiments, and it helps to predict and quantify plant characteristics and behavior in non-destructive manner. It helps also in the management of crops, landscape, forest, disease, and pest control. It helps to adapt the system into climate changes and plan future productions. It helps also in decision support systems to provide real-time recommendations. It improves the farm management and the production process. So we have two ways of developing a virtual twin of a plant. It's either using large amounts of data to have an IA model, or using our knowledge and understanding the dynamics to make a mathematical model. So either a data-based approach or a knowledge-based approach. And so in the database, we collect data, we clean it, analyze, extract features, do statistical tests, develop the model based on a machine learning algorithm or an artificial neural network, and use the model for predictions and simulations. In the second type, we understand the mechanisms and the relations between the variables. We develop a model based on physical laws, biochemical principles. We calibrate the model using less data in this case, and we use the model for predictions and simulations, and the models can be used in reinforcement learning to test management practices. So now let's go to our case study. We studied the case of infection caused by PSA bacteria in kiwi fruit, which provokes the kiwi fruit bacterial canker disease. It causes a lot of damage in kiwi fruit vines. We can see the symptoms here on the leaf, which are necrotic spots. It causes the death of a lot of tissues, and it causes bleeding with whitish to red exudate. And it likes warm environments between 18 and 25 degrees and a lot of humidity. And when there is low temperature in the preceding winter, it helps spreading the bacteria, the disease. So this disease has two stages of infection: a biotrophy stage where the bacteria infects the plant but doesn't kill it. These symptoms will not appear, and it will compete with the plant for its resources. And the necrotrophy stage, where the bacteria starts degrading plant tissues and symptoms starts to appear, and eventually it will kill the plant if the plant doesn't recover. So let's go to the formulation of this. We have a mathematical model of, we have the basis for the mathematical model of the kiwi fruit growth. So plants use the light energy and convert it to chemical energy in a reaction of photosynthesis, where it converts carbon dioxide to oxygen. So this light energy is intercepted by the leaf area of the plants, and it performs photosynthesis to produce dry mass, which is carbon or glucose. And this chemical energy and glucose is distributed between the organs for growth purpose, according to the growth, depending on the growth stage and the organ priority. And later, then in the case of infection, the bacteria will come and compete with these organs for the carbon energy. And later in the infection, this bacteria will destroy the leaves that are performing photosynthesis. So in the model, we had to design an environmental conditions as inputs to the model. And here we designed, we proposed this temperature and daily temperature and irradiance distribution. So we have here in the blue, we have sunrise, a photo period of 16 hours. We have sunrise, midday, and then sunset here. And for the temperature, we have the highest value in the afternoon here. And these are generated using these equations. Of course, a variation between -2 until 16 or until 23 is too much for the temperature, so we reduced it later in the simulation. So for representing the growth of an organ, we designed a mathematical model. So S is the size of an organ, and alpha is the age or the developmental age of the organ. So the size of the organ is controlled by two functions. F is a priority function that controls the organ priority in the growth, depending on the concentration of carbon in the plant, and G is the growth function of the organ itself. And to represent the growth of the leaf, we can use this equation where F is the same function, and G is given by this, where this function limits the growth of the organ at the end when its developmental age is high. So we apply the same thing for the internode, except that the internode has a primary growth in the length, then secondary growth in the radius. So we apply the same thing for the length case, and for the radius. And then we gather these two variables using the volume and volumetric density to get the final size. And root growth depends a lot on the temperature, so we suppose the continuous growth whenever the temperature is suitable for it. And for the fruit case, experiments have proven that it follows a double sigmoid growth, a double logistic growth. So we designed the equation to be like this, and of course, together with the priority function. So for respiration, it's a function of temperature, and it also consumes carbon depending on its priority. For the carbon acquisition by the leaves, it depends on the amount of carbon acquired by photosynthesis, and it is limited by the total size of the leaf. And G here is another priority function depending on carbon amount made by the leaves. We have also the reserve dynamics. Carbon that's not used is stored in reserves. We have the synthesis of starch here, which is carbon storage, and the hydrolysis, which is carbon used from the storage. So concerning bacteria, PSA bacteria that causes the infection, we proposed a model based on population dynamics. It was a Malthusian model that gives the difference between the birth or the reproduction of the bacteria and the death. So we have reproduction dynamics here. We include in the first line, we included weather effects, like here temperature effects, humidity effects, nutrients effect, which is carbon concentration, and physiological state of the bacteria, if it is mature enough to reproduce, if it's a delay function that gives bacteria time to adapt to its new environment, which is the plant. And we have death dynamics also that relates to the temperature and humidity. And Q here is the physiological state of the bacteria, is another variable that is related to the bacteria. And at the end, we have a carbon balance equation. So this equation computes the available carbon after each time after consumption and production by these organs. So we have the carbon produced by the leaves and moved from the reserves minus what has been consumed by the organs for vegetative growth, fruits, respiration, and the bacteria at the end. And for the necrotrophy stage, we have when the bacteria population increases too much, it starts necrotrophy stage, and these symptoms start to appear. They are represented by this equation, which are, and symptoms are usually dead tissues. So they are proportional to the size of the population. And then this dead tissue is removed from the equation of the leaf, internode, fruits at the end, by adding this term. So after implementation of this model, we get these results. I don't know if the figures appear. So we have here photosynthesis. We have, it goes up and down because day and night. We have zero during the so we have zero during the night, and we have that curve that I showed in the beginning during the day, the curve of light. And here we have the difference between the infection case in red and the healthy case in blue. And this green line is the bacteria inoculation time. We have a short biotrophy phase here. Leaf sink size also follows the same behavior because it's the leaves that perform photosynthesis. Internode, amount of internode tissue also reduces due to infection, and the roots also. But the roots, I think they are less concerned by this infection, so they reduce less. Sorry. So, and we have fruits. The amount of fruits is also affected by the. Sorry. Here's the mouse. So the amount of fruits is also affected by the infection. We have the source here. The leaves try to make their maximum effort to replace the carbon consumed by the bacteria. So the source increases just a little bit. And we have the reserves also decrease in the internode and in the roots. So this simulation is an approximation. It's not the real simulation of the model. It follows the big leaf approach. Like we use one big leaf instead of all the leaves, one big internode instead of all the internodes, and the same for the other organs. So if we use one equation for each organ, for each leaf, for each internode, this will be very high cost, very high computational cost, and difficult to solve, but it can be done. With the same model, it can be implemented. So here we have the available carbon amount. We see the difference of carbon consumed by the bacteria. The difference here is the amount consumed by the bacteria. We have the bacteria population size here. We simulated for 3 months, by the way, or 4 months. And we suppose that the temperature will start low and then increase. So the bacteria start dying after when the temperature increases in the summer. And here they grow very fast when the temperature is suitable. This purple line is the beginning of the necrotrophy stage. So we have also the amounts of symptoms increase in the leaves and internodes. So we tried to compare this model, simulation of this model with experimental data. We have photosynthesis data acquired using ILGA device, which is infrared gas analyzer. So we have, I don't know if it appears, we have the big dots are the simulation results. The stars are the average of the data. We see that simulation results are close to the average of our data, and the small dots are the data itself. We also have the symptoms. There. So they are also compared with data at 3 time steps. And we can see that our simulation is close to the red dots, which are the average of the data of that we get from experiments. So in conclusion, we developed a mathematical model based on carbon resource competition between kiwi fruit and the bacteria that infects the kiwi fruit. And the model contains three parts: functional model of the kiwi fruit plant, bacteria population dynamics, and carbon balance inside the plant. And the model can simulate two cases: the healthy case if you remove the bacteria population, and the infection case without any defense from the plant. So defense dynamics can be added later easily to the model. And the model includes the environmental effects on both plant and bacteria. And the model can be implemented in a reinforcement learning algorithm to find and test different disease management techniques. So, and that's it. Thank you very much.
Thank you, Anna. One shot question.
We have you analyze the effects of plant growth as function of type of light. No, we did not analyze this. Spectrum wave.
The question that we can
Yes.
don't you mind to repeat
Light.
the question?
Light presentation in the lightning model test. Did you analyze the effect in the plants grow as a function of type of light? In other words, so spectrum, wavelength, energy, and time.
We didn't consider the wavelengths because we considered like sunlight. The values here are converted to ppfd using by supposing that the type of light is sunlight, and the model includes the effect of light intensity, not the light wave. So the intensity of light, we have the photosynthesis. Can you go back? We have the photosynthesis that is here. The equation shows that the photosynthesis is a function of light. So we have light here. It's light intensity, and it's converted to ppfd, of course. Okay. Any questions?
Yeah, so the
Yes.
experiments, where were the experiments? Were you?
In growth rooms here, in growth chambers. Yes. Yes. The light is different. Yes. So
But I agree with you that light intensity will be. This is the first approach, so
yes, yes.
start with light intensity. That is the most triggering thing for the development of the plant as well.
Well, anyway, even if light is different, the same variable is used for all types of light in this model. So we used the value from the growth chambers and to generate the simulations that are compared with the experiments.
And Osama, would it be easy to integrate a more dynamic evolution of photoperiod for different seasons in the year?
Yes,
Because
it can be done.
You utilize a fixed
Yes, 16 hours, but it can be done easily. Yes, you replace the constant by a variable, and you give it its values. Like you put a vector of values from winter to summer, for example,
Okay.
of the photo period. It can be done easily. So, any questions?
Okay. So, on the last speaker will be Katia Briggs, close to the first session. Use of spectrometry in vegetation studies, application to tree and Cataranthus plants.
So, which one?
This.
So, this is laser, this is to go forward, and this is working.
Bom dia a todos. Nós vamos apresentar a nossa contribuição para este projeto, que teve a ver com a análise.
Faz mais um bocadinho ali para fora do alcance da câmara. Isso, aí
Teve a ver com o uso do espectroradiómetro, ou seja, a análise espectral ou hiperespectral, neste caso, portanto, de algumas espécies que nos foram dadas para criar, então, o que nós chamamos de bibliotecas espectrais e tentar perceber se os comportamentos nesta assinatura espectral são ou não alterados mediante algumas condições que também são alteradas no ambiente destas espécies. Nós pertencemos ao ICT, Instituto de Ciências da Terra, e a nossa área de trabalho é a detecção remota. E eu vou só fazer uma pequena introdução relativamente ao que é isto do espectroradiómetro, portanto, e o que é isto do que nós fazemos. Normalmente nós trabalhamos com o espectroradiómetro, que é uma técnica, digamos, local, que nos permite normalmente validar e calibrar os dados que nós obtemos por detecção remota, e aqui a detecção remota está mais relacionada com dados obtidos por satélites, por aviões ou por drones, que hoje é muito comum, não é, usar drones, e este tipo de aparelho, o que é que me permite? Permite-me então perceber qual é o comportamento de onda, mas de uma forma contínua e não discreta, como um satélite obtém, ou como um avião, que tem determinadas bandas que são discretas em determinados comprimentos de ondas, e essas bandas são discretas devido à influência da atmosfera que me provoca um efeito que se chama absorção e não me permite usar de forma contínua todo o espectro eletromagnético. Se eu usar estes aparelhos que são, portanto, on the ground, portanto, são no local, eu não tenho a influência da atmosfera, portanto, eu consigo gerar um espectro contínuo. Neste caso, nós estamos a usar um espectroradiómetro que vai desde os 400 nanómetros a 2500 nanómetros, portanto, visível, infravermelho próximo e shortwave infrared, sem nenhum tipo de gap. Portanto, temos espectros contínuos, o que nos permite identificar características muito importantes das espécies, o que nós chamamos os picos de absorção e os picos de absorção, e com isso distingui-las e tentar determinar ou dar a análise para os colegas que percebem disto, que não somos nós só analisamos os espectros, que tipo de comportamento é que aquela alteração pode ou não estar associada. E foi então este tipo de abordagem que nós quisemos trazer para este trabalho, porque nós temos este aparelho, temos muita experiência na criação de bibliotecas espectrais. Isto nós chegamos ontem à noite de trabalho de campo e ainda estamos um bocadinho trocadas na criação de bibliotecas espectrais, na sua análise, e depois a disponibilização para os experts, para a Susana e para o seu grupo, para realmente poderem interpretar este tipo de informação. Portanto, achamos que é aqui uma mais-valia para este projeto, esta experiência que nós temos e também, obviamente, este aparelho que nós temos, que é de veras bastante útil. Está aqui uma fotografia do aparelho, portanto, é um ASC Field Spec 4, que tem diferentes resoluções dependendo do tamanho das diferentes gamas. Nós usamos um dispositivo de contacto, portanto há um contacto direto entre o dispositivo que vai ler, portanto que vai fazer a recolha da assinatura e neste caso a folha ou a planta ou o fruto que vai ser analisado. E depois vamos então, há um processo aqui um bocadinho mais chato, que é uma calibração. Nós temos que fazer uma calibração para o preto e para o branco, que é o 0 de refletância e o 100% de refletância. Nós trabalhamos com refletâncias, que é uma medida física absoluta, também podemos trabalhar com radiâncias. Portanto, há aqui uma série isto foi tudo a Cátia que fez, e outro bolseiro que também esteve envolvido, o Douglas. Portanto, há aqui sempre um processo, porque este aparelho pode ser usado em laboratório, portanto, em condições, ou também tem outro dispositivo, ele pode ser usado também, por exemplo, este é um dia fantástico. Se eu, por exemplo, quiser usar este aparelho para calibrar imagens de satélite, devo usá-lo em condições exteriores e não condições de laboratório. Nós trocamos a probe e fazemos outro tipo de medidas, uma calibração completamente diferente. Ontem, por exemplo, tivemos esta semana em Montezinho também a ver diferentes tipos de folhas de plantas, para um grupo mais da biologia, da biodiversidade, e também usamos outro tipo de probe para fazer outro tipo de análises. Portanto, é isto mais ou menos o objetivo, é esta a metodologia que nós usamos. Depois temos que aplicar filtros de remoção de ruído, remoção de contínuo, a identificar os picos de a absorção da água. Portanto, depois há aqui uma metodologia com que nós trabalhamos. Agora a Cátia explica que ela que fez o trabalho, portanto, não vou ficar briga.
Bom, como a professora comentou, como nós temos os dados em contínuo, a gente consegue fazer uma série de análises, desde a análise do próprio espectro, quanto índice de vegetação. Aqui é só um follow-up dos projetos que nós participamos. Inclusive, aprendemos muito, né, com o Miguel e com a Marisa, e com o apoio da professora Suzana também. Então, nós fizemos no Catarantes 2 projetos, dois períodos de coleta. Esse projeto vai ser apresentado mais tarde, então eu até falo um pouco sobre os resultados, mas a Marisa depois fala com mais domínio. E também o Miguel está aqui, e nós fizemos dois processos de coleta, e fizemos aqui os números dos espectros coletados. Enfim, de novo, né, como a professora comentou, a gente tem os dados por cada uma das faixas e depois a gente consegue fazer cálculos de índice de vegetação, que foi o que eu comentei para vocês também. Então, o resultado que a gente apresentava para o Miguel e para a Marisa é essa planilha de Excel, com todas as informações das coletas e com uma breve análise desses índices que eram calculados. Nós fizemos uma fórmula, então ele é calculado automático, e os espectros também que são gerados. Aqui é um exemplo, é um gráfico dinâmico, então conforme seleciona a coleta e a vegetação, se cria esse espectro no Excel, para não precisar ficar abrindo imagem por imagem no espectro que a gente disponibiliza, porque é um PNG. E aqui a teoria, então nós conseguimos, pelos picos que a professora comentou, de absorção de refletância, identificar a área de absorção de água, como é a questão da área de clorofila, que é essa parte que foi que a professora comentou também, que o Miguel e a Marisa analisaram. E a gente consegue ver aquelas curvas típicas da vegetação, que é a red edge, e outras informações. O espectro teórico, e esse é um espectro do que a gente coletou, então a gente percebe que tem uma proporcionalidade. E a ideia, por exemplo, com os índices de vegetação, é fazer o cálculo para avaliar a saúde da planta, se tem ou não tem, a questão de como está as taxas fotossintéticas. Então, todos os índices que a gente consegue calcular a partir dos dados espectrais, a gente consegue, porque a gente tem essa vasta informação e a gente consegue fazer, por exemplo, a comparação entre uma coleta e outra, entre uma planta e outra, enfim. Aqui é uma apresentação que nós fizemos no ICT, como resultado do trabalho, e que nós identificamos que existia uma correspondência entre o NDVI e as taxas fotossintéticas a partir dos dados analisados. Esse outro trabalho foi um pôster apresentado pela Marisa, que provavelmente ela vai falar no período da tarde, e que também foi identificado que o espectro colaborou para fazer identificação, por exemplo, da análise do estresse que foi submetido à vegetação, depois ela explica um pouco melhor. Então, a ideia que a professora comentou também, quando a gente usa um espectro, não precisar danificar alguma coisa da plantação, da vegetação, então a gente consegue fazer a mesma validação na mesma folha durante um período X de tempo e fazer esse acompanhamento de como as taxas aumentaram, diminuíram, sem precisar danificar a folha analisada. E esse é um pôster que foi submetido pelo Miguel, e também, em uma das conclusões, a gente trouxe algumas conclusões aqui, mas que também a análise do espectro radiômetro foi importante para analisar, porque o trabalho do Miguel tem a ver com contaminação dos kiwis para avaliar possibilidades de combater que essa contaminação avance. Então, pelo espectro, a gente consegue ver as taxas de saúde dessa vegetação e atuar de forma preventiva sem que tenhamos alguma questão assim, de ter que danificar a planta, como eu comentei anteriormente. Então, o fato dela não ser invasiva é uma mais-valia, então preserva, né, as funções físicas e químicas da vegetação, do que a gente está analisando. Os resultados foram possíveis para analisar o estresse que a gente avaliou no projeto da Marisa. A gente também consegue avaliar pelos índices de vegetação a saúde, e aí, assim, cada projeto é muito específico, porque cada um vai ter, por exemplo, eu quero analisar a parte fotossintética, então vai ser um índice de vegetação. Quero analisar a saúde da planta. Então, também, nós montamos uma metodologia juntos para preservar e também personalizar cada uma das análises. E a replicância foi importante para identificar essa contaminação que o Miguel realizou nas vegetações. E é isso. O que a gente, assim, agora pessoalmente aprendeu muito, porque nós usávamos muito equipamento para análise de rocha, lá na faculdade. Então, analisar a vegetação foi um período de muito aprendizado e que a gente, pronto, pôde colocar em prática esse conceito mais da vegetação, de como que a gente pode identificar essas questões. Tá bem? Muito obrigada. Não sei se tem dúvidas.
Obrigado pela apresentação.
Eu tenho uma. Não, é que o aparelho emite uma luz, não é, em todo o espectro, é isso?
Isso.
E depois recolhe.
Imagina,
O que tem que estar encostado?
Aí depende do método. Por exemplo, se a gente vai em campo, se tiver luz, é o que a professora comentou, a gente pode usar uma outra pistola que é de apontar. Então, eu consigo calcular, por exemplo, o FOV, que é a área de visão desse sensor a partir da altura que eu estou medindo e da angulação. Então, eu consigo fazer uma medição de uma área um pouco maior do que essa mais localizada. Mas como nós estávamos fazendo a nível de laboratório e nas plantas tinham folhas específicas que foram contaminadas, por exemplo, no caso do Miguel, a análise foi mais pontual mesmo, até porque durante o período as folhas que foram contaminadas mudavam de cor, então a gente queria pegar exatamente aquele foco com algum tipo de alteração.
Até mesmo localizado.
Exato. E pronto. Quando a gente vai externo, a professora comentou também, a gente tem outros fatores. Quando a gente está em laboratório, é controlável. Então, vamos dizer assim, a intensidade da luz vai ser igual para todas. Então, a gente consegue identificar se aumentou ou diminuiu em níveis muito pequenos, muito sutis. Mas isso não impede, de repente, fazer uma coleta de campo e não precisar apontar. Não precisar apontar e não apontar sim, né? Não precisar, tocar na folha.
Obrigado. Há perguntas no chat?
Aqui não. But I have a question. If in English, if possible.
I will try.
When you are measuring a leaf with the measurement tool, you send the spectrum of light, like Professor said, and you measure what was reflected. This is what the tool does. How do you know if there is no wave, no like infrared light or something that penetrates the leaves and goes out from the other side? And you think that the leaves absorb this light?
Okay. We use a black paper to.
Yeah. Okay.
Yes, and you use a glove.
The gloves in the picture were white.
No, it's it's the first time, but the result's not okay. After we
okay, you changed. Okay.
Yes, and
okay.
Use a black.
Okay, thank you very much.
You're welcome.
Nós temos aqui previsto uma sessão de debate, já estamos um bocadinho fora do tempo, portanto, o que proponho se houver perguntas gerais que queiram fazer agora, então se vou fazer. Se não, vamos para o coffee break e no final promovemos um debate sério. Mas se houver alguma pergunta que acham pertinente fazer-se agora, não? Então, vamos ao break e estamos aqui de regresso às 2h15.
I need your help. Perhaps you can help me. Yes, I know what is the problem. I can help.
The sound is good. Something behind it.
Oh, gosh.
Okay.
Okay, the microphone is the problem.
Yes, yes.
Good.
So this is the presentation.
Yeah, yes, that's the one. I'm going to call.
You can start.
Você quer start?
Yes.
Ok, não sei se devo falar em inglês, em português, o que é que preferem? Eu acho que a maior parte da plateia é portuguesa e estão aqui algumas pessoas da uma. Sei, estou dividida. O que é que eu falo? Língua. Okay, so then I will talk in English. I think most people, there are some people here that are not Portuguese speaking, so it will be better. Okay, so welcome to session number 2. I'll be sharing this session, and at the same time, so I have to control myself in terms of time to give the example. What I will present now is related to research line 1. So we put the order in opposite of what it will be expected because we had some people that had to leave. And I will present you work package 1. Work package 1, as I mentioned before, is related to microgreens. So production of microgreens in plant factories. And what we have looked, this is one line on microgreens. The next line will be presented by my PhD student, that is Marisa Lorenzo. She will be online. She cannot be here in presence, unfortunately. And the work that I'm presenting here has been developed with several people, that some of them are seated here, Joanna, Bruce, so some MSc students, and also some collaboration with Marta that is here and Isabel Ferreira that are from the Faculty of Pharmacy. So it's a joint work. Sorry, I forgot that.
It's not working.
So microgreens, I guess most of you don't know what is microgreens. Perhaps you have heard about sprouts, portanto, germinados, não é? But microgreens is something a little bit in between, because you already have the leaves. The leaves are present, so they have chlorophyll. They are more rich also in terms of nutritional compounds. So they have tender immature leaves. They are harvested when the cotyledonary leaves have been developed. So they have the first true leaves are appearing. That's the moment of the harvest. As you can imagine, this is not a very long cultivation period. It can take about 8, 12 days, depending on the species, okay? 12, sometimes 15. These are really very much in fashion, and they are, as you can also imagine, they are very well adjusted to growing in vertical farming because they have very short cultivation cycles, and they are also very small plants. So you can really pile up a lot of this type of plants. They are not grown, of course, as single plants for your planting and so on. We grow them in trays, in little trays, and they are sold. Also, they can be sold in these trays because they will keep more fresh, or they will be cutted and put in plastic and delivered in that way. So this is really a trend with companies that are working with vertical farming, okay? Is really growing the amount of production of this type of plants. They have high concentration of nutraceutical compounds that we have a potential health benefits, and that's one of the reasons why they have been so attractive. Many chefs, como é que se diz chefs? De cozinha? Many chefs. Chefs are also very fan of this sort of Michelin chef are very fan of this sort of products, and that's another thing. They have high economical value. That's what is also making them quite attractive. What we have studied in this project was mostly focused on light, as you have already heard this morning. Light is really one of the most important factors, and in terms of plant factory, that is extremely important because you can control light at a very in a complete different way that you would do in the outside when you are growing in open fields. Also in greenhouses you can control somehow, but with the plant factories is definitely the growth production system where you can control light in a more precision way. So this opens totally new doors, and also for research is very interesting what you can do when you can control light, quality, intensity in the degree that you can do with plant factories. So the thing is also that the light, we know from the physiology that the plants, they don't respond, although Osama was talking about light intensity is one of the most important parameters. That's totally correct. But the thing is, when we are giving the white color of the light, you are giving the full spectrum between 400 and 700 nanometers. So you are giving all the visible light. And we are also interested, and that's what is happening a lot in plant factories, not giving the full light. Why giving the full light spectrum when the photosynthesis have peaks mostly on the red and on the blue? That's why when you see photos from vertical farms, you often see this is the color that are mostly used, because from the knowledge it's already known that the red lights and the blue lights are one of the most important lights in terms of light quality that play a role in photosynthesis, in plant development, and that's where the absorption of chlorophyll has a peak. So then the idea is just to give that light instead of the full spectrum. But we didn't know, and there is really a total knowledge gap in terms of how this light impacts the growth of microgreens. And the other thing also that is really quite new is that the use of ultraviolet UV light, because you know that UV light is quite aggressive. UV light is mostly used, especially when we talk about UVC, is used for disinfection. But here the idea was to trigger the plants, because UVC is a wavelength that is really also the plants are quite sensitive to it. So the idea was to apply very small amounts in specific periods, what we call hormetic doses of UVC. So very specific, triggering the plant a little bit when the plant is already somehow developed, and try to see if challenging the plant with this light that is aggressive would increase the production of secondary metabolites. So that can be compounds that are more beneficial for health. So in terms of antioxidants, flavonoids, and other sort of compounds that will increase the quality of this microbean. So that was also our idea, and that's what we know, and this is what is not well explored, and that's what we want to focus. So we have done two experiments. One experiment, so both of them, as you can see, they are quite similar. They have changed in terms of, these are Brassica family. Brassica family is one of são as couves, não é? Família das couves, nós dizemos. Brassica family is one of the families that are mostly used for microgreen production. And we have looked at red mustard and at red and green radish. O radish é o rabanete, está bem? Portanto, mostarda e rabanete. So these were the two species that are when we have first looked into literature, we didn't know which ones to choose, so we came to this choice because they are the most common ones. So we applied to these UV lights, and in the first experiment, just look at the effect of UV light in terms of yields, quality, and metabolic profile. And in second experiment, we also introduced another comparison that was the white light compared with red-blue. So to try to see if we will have a difference. So this is I'm not going in detail, so this is the way that we have done, so the material methods, but just that you have an idea. These are quite small trays. I will show you some photos later on. Even the amount, the density, the amount of seeds that we should put in each of the boxes, let's say, was not totally known. So we we lost in the in the beginning of the project, we really had to try to find which will be the right density, several details of, because this, I know that there's here a company and they are, this is quite challenging. And the plant factory that I visited in Denmark, they had tried microgreens and they found it, because they are more used with baby leaves, and they found it quite challenging because they have to be pressed, because the seeds, and in practical terms, it's not so to have a very homogeneous germination. So now we know how to do it, but it was really a learning curve. So this is how the plants were looking like. You can see that it's very dense, so like a sort of tipo de tapete glass. Let's say. And this is our species, and the treatments were the red mustard. We had control, which did not receive any UV. We applied UV light during only one day, okay, one day with the intensity that I mentioned before, and then we applied 3 days. It was really very nice to see that when we applied one time, the plants were really triggered. So this was going exactly with the idea of the hormetic doses. But if you apply more, they would already go back to control. Perhaps if you would apply even more, it would go to worse than our control. So here we can see that actually this really works. And here you saw that we can see that dip of fossil is one of the measurements, that the plants were shorter with higher doses. So definitely it seems that there is here this hormetic effect playing a role. Another interesting thing was that we have seen, we have also measured several parameters. I'm here just bringing some of the information. For most of the nutrients, because we looked at nutrient composition, for most of the nutrients, there were no significant differences. But interestingly, for iron, ferritin iron, there was a significant increase with UV light. So 3 times increase. Here is, I'm afraid that the colors disappeared. Strange. And you can see the colors, right? They are there. So the
green
line
left
yes.
cluster and red left the right cluster.
This is cluster, and here is another cluster. I don't know if no, then the percent, they are totally gone. Yes, they are totally gone. So what you see is here like a cluster with one color, and here a cluster with another color. And what you can see is that there is really a split, and this work was developed by Marta, that is there, from Faculty of Pharmacy. And what we can see is that UV light, the frequency that we apply UV light didn't play a role in terms of the metabolic profile. But when we compare UV with the control, the plants were really behaving differently, okay? So we had 2 clusters, one cluster for plants that are control plants and another cluster for UV plants. So definitely UV light is playing a role in terms of the metabolic fingerprint and phytochemicals fingerprints. And then we look more closely which were the metabolites that have been produced or enhanced when you are under the UV light. So we have identified, Marta has already prepared, here I can see a little bit of the color. Marta has already prepared a manuscript that we hopefully will submit soon. And so here they are different compounds that have been differently produced, and they are very much related because this is the family of Brassica. So and they are very close to Brassica. These are typical compounds from the Brassica family. Okay, so this second experiment. So the first one was on mustard, and this second experiment is, as I mentioned, in radish. We made some adjustments, and since the cultivation period is not the same, so we first had always to try to see how much is the cultivation period. And then when we decide to apply also 1 time or 3 times, since we apply at the end of the cultivation, UV, we need to know, of course, when is the end of the cultivation. So we should do 1 trial, we found out the time that it will take. And as you can see, then we move to this sort of smaller containers. And that's how the plants were looking like. and we have the green radish and the purple radish. And what you see here in this species, it's different from what we have seen before, because here we don't have an effect of UV. Okay, so UV is here. We don't have an effect of UV, no significant effect. Where we really see an effect is when we are comparing the white light with a combination of white and blue lights. Okay, so with the blue, red and blue, the idea that they are the peaks where the plant absorbs more and is more efficient in the production, it really happened with this species. But not, I'm sorry, going backwards, but not with the purple radish. So this is really, seems that every case is a different case, which unfortunately make that we cannot draw really conclusions that are applied to everything. So in terms also of the fresh weight, it happens the same thing. Dry weight, the differences are not so big. They are not significant. And in terms of plant height, we could also, that was even visible that the plants that were coming from the red blue, the plant height was higher. At this moment, we are performing, because this experiment finished not so long ago, at this moment we are performing also as well an analysis on the nutritional composition to see if the nutritional composition will be affected and or not, and that's where we are. And now coming to the conclusions of this part of the project. UVC enhances yield in red mustard, but only when applied in normative doses. Otherwise, it can even have a negative effect. Plants that grow under UVC light, they show distinct metabolic profile, but no effects have been observed when we compare different UVC frequencies. And for the second experiment, we see that unlike red mustard, yield was not significantly affected by UVC, but red and blue light clearly increase yield when compared with white light. Okay, so I would like to thank, of course, the team that has been involved in this work, and I'm open for questions. Thank you. I think there are some questions there.
No, I haven't.
Yes.
So in this last experiment, there was no, you couldn't see the major difference, right? But you didn't even analyze the iron stuff.
No, we didn't. We still didn't evaluate. It can be that there is no influence in terms of yields, and it can be an increase in terms of quality. Yes. And one thing that I didn't call much attention, because the idea here is that we just apply UV lights at the end of the cultivation periods. Because if you apply UV from the beginning, since UV is very aggressive, the plant is still starting germinating, the beginning of the growth. So from literature, normally what is mentioned, but this is still all very new, is that might be too aggressive for the plant, and then you are reducing your yields. Actually,
I have a question.
yes.
So, when applying these UV lights and the far red light treatment, if you have on the shelves LEDs that can deliver these lights, this treatment can be applied on the shelf, or they need to be taken to a special room or something?
That's a very good question, because the thing is, UVC is an expensive lamp.
Yes, yes.
So if they could be, I would say that they can perfectly be applied in a shelf, because you know that with the shelves you can have like dimmers, and you can control that the lamp will just be switched off. From technical terms, that's totally possible. The thing is that since UV is expensive, what I would advise, and that I have already seen that applications like this also as prototypes in greenhouses, is that you have a lamp that moves. Because the lamp just needs to, the plants just need to be exposed for a few seconds. So it will be there for a few seconds, and it will move a few seconds, and then they will cover. And of course, I also advise during the night, because UVC is aggressive for human beings. So this should be done during the night. The other thing about doing it during the night, I can also share that with you. in most countries, the energy costs are lower during the night. So plant factories, they often work that they have the lights also a large part during the night instead of having during the day. Of course, they have the workers to check them, so they keep them at some hours still in the morning that workers can check and do things and harvest and so on. But then they switch it off to save some energy, so can be an important thing.
Yeah.
For
This
energy
question
saving.
was because I asked this question because in the remote control we consider the remote control of three types of light: UV light, far red, and the grow lights in the far region. So three together that can be controlled remotely with temporary treatment, like you switch on, then you switch off, with a certain duration of light treatments in the UV and far red case.
Yes.
So this is why I asked if they can be done in place or you need to move.
No, they should be done in place. I think moving it will cost a lot of energy for the movement and so on, that it will be
and disturb the environment.
yes, it wouldn't be very practical.
Thank you very much.
Thank you. So we move to our next speaker. I hope she's online. Marisa, she's not?
I am.
Thank you. Okay. Hello, Marisa. You are already switching on the camera. So I suggested to present in Portuguese, but at the end we decided to do it in English. So you don't mind to present it in English, right?
No, of course not. Well, it will be a little bit challenging now because I just trained in Portuguese, but it's okay. I think it won't be a problem. Let me just share my... everybody hears me quite well, right?
Yes.
Yes, okay, good.
Wait. And do you see my PowerPoint?
Yes, we can see. You can put full screen and start.
Okay. So hello everyone, my name is Marisa Lourenço. I'm a PhD student in Porto University from Green Porto, and today I will talk about the role of UV radiation on the simulation of anti-cancer alkaloids that are produced by Cataratas roseus. So as Susanna was just talking, vertical farms are really increasing their importance nowadays. So in the near future, I think this will be one of the ideas that we really have to concern ourselves for the production in long-term future for all of our population. And besides that, some of the most important characteristics of a vertical farm is that we can have the production in a closed system. So we are not going to imply the things that we are applying on these cameras outside. So there is no environmental impact, or at least is lower. Also, we can control all of the climatic parameters inside of these chambers. And so we can have a more productive plant coming around. So we can have a year-round production of this type of plants. And also, as Susanna just said, we can maximize the production per square meter by having more and more layers, as we can have in these type of facilities. And we can move these facilities to inside of the urban areas, so we can ensure the distributional channels, also making it more efficient to get to the final consumer. And nowadays there is a lot of investigation and also already a lot of production on the leafy greens, so some lettuce, some aromatic herbs, and also some microgreens, as we just talked now. But there is being more incidence nowadays on the soft fruit, so some strawberries, for instance, and also on cannabis, because cannabis is one of the crops that is more we can have more return from it, so it's more profitable. And some years ago, when I started my PhD, I was challenged to start the study in other medicinal crops that could have also a high profit, so high return value, so we can actually do the investment that we are applying on a vertical farm we can get to a break-even layer. So why not other medicinal plants? And this is why I bring you Cataratas roseus, because this plant is not only an ornamental plant, but it is also a medicinal and aromatic plant. And this plant can produce important anti-cancer alkaloids. From the alkaloids that the plant can produce, vinblastine and vincristine are quite expensive, and nowadays they are just produced in pharmaceutical industries, so synthesized, so they are just synthetically produced, and we can extract it directly from the plant. So this is actually also a plant that we can see that has a short growth, so it's quite short comparing to other plants like cannabis, and also it has a quite fast growing cycle, so it's quite suited for vertical farms. What is known about Catharanthus? So we know it's original from Madagascar, and the pharmaceutical industry already studied quite a lot the Catharanthus roseus, and we also know that the best light intensity to induce alkaloid production is between 150 and 300 micromole per square meter per second of ppfd. It is also known that the UVA, when we supplement the daylight with the UVA, we are increasing the vinblastine production. However, the UVC impact is not quite well known yet. But still, we believe that there is a favorable input for the plant if we apply the UVC. So the knowledge gaps that I tried to study during my last 3 years of PhD, one of them was to actually assure what is the best cultivar that we can use in vertical farms, so in this type of productions. So which cultivar is the best? Then what will be the effect of the long term of UVA being applied during all cycle? So not just a little bit at the end, during the all cycle. Also, what will be the difference if we apply a monochromatic or a dichromatic, a dichromatic or a polychromatic light spectrum. So again, as Susanna was saying, of course, that red-blue, it's more efficient, more towards to the plant production, but also we wanted to check in Catharanthus roseus because this study was not done yet. And also we wanted to see what will be the benefits of different UVA dosages and also UVC, so different intensities, how will it impact the alkaloid production on the Catharanthus roseus plant. So our objective is to expand our knowledge on the effect of the UVA, UVC, on the morphophysiology and on the alkaloid production on Catharanthus roseus, and also to get to the best recipe to produce a higher amount of alkaloids in the best species within Catharanthus roseus. So from the experiments that we have conducted, we started with the screening. So we wanted to see from 9 cultivars which one was more adaptable for this vertical farming systems. And also we have applied already 2 different light spectrums, light treatments, I'm sorry, the same light spectrum, but with UVA or not at the end. And we wanted to check if these plants could be more productive or not. And so from these, we have selected 3 cultivars. I will explain it forward. But then on the second experiment, we tried to see what will be the difference between a dichromatic or a polychromatic light spectrum. Again, always with UVA or not at the end. Then with the beginning of the SNAP project, we wanted to focus more on the UVA impact on the production. And so we then started to look on different intensities, so more UVA applied at the end of the day, so 2 hours, 4 hours, and 6 hours, again, the same cultivars. Finally, we also wanted to check the differences between the same intensity of UVA, but instead of UVA applying in UVC, so a shorter wavelength, and we wanted to see how the plant will perceive it. And our final experiment was on the different intensities of UVC. So these 2 last experiments were, we just applied at the final 5 days of the experiment, because of course UVC is too harmful for the plant. And so we need to be more concise. We cannot do a long-term application as we did with UVA. And so here we have also different intensities being applied. So I started in 2020 with the experiments. In 2021, I did also another different experiments besides the light ones. And in 2022, when we started with the SNAP, we focused more on the UV. The methodology that I have carried was, I started with the 9 cultivars, as I was just saying, and I did the screening. And from these, I selected these 3 because Polka was the one producing a higher biomass, Red was the one producing a higher total alkaloid concentration, and Apricot was the one producing a higher anti-cancer alkaloid concentration. So I grown the plants in 8.5 centimeter pots with a substrate of 50% humus, 18% peat, 17% perlite, and 15% cocoa peat. They were grown for 4 weeks. With all of the parameters monitored in 3 minutes, so the temperature and the relative humidity. And between different experiments, I used a different light spectra. Each one of them, we had 5 experimental units, and they were replicated 3 times. So this is how they looked like. At least one of the experiments looked like this. So on the first experiment of the screenings, just for you to remember, there were 9 with 2 different light spectrums, okay? And so from the first experiment, we didn't see a difference, a significant difference between the application of UVA after the control. So it was not too harmful for the plant. The plant was not producing less total biomass, but there was a significant interaction between the cultivar and the light. But yeah, it's more cultivar dependent than light dependent, this response. As well, we can see that the alkaloid concentration has the same response. So it's not dependent on the UV that we are applying. It's dependent mostly on the cultivar. But if we look on the anti-cancer alkaloid production, we have here a superstar, a Sunstorm apricot. So actually we could achieve a higher production, so more 584% of anti-cancer alkaloid being produced in Sunstorm apricot comparing to the remaining ones. And if inside the anti-cancer alkaloids, if you look on the vinblastine, we can see that there is an increase of 207% when the UVA is applied. So this is quite good result. So no impact at all at the total dry matter, and we can have an increase of vinblastine, so this anti-cancer alkaloid happening. So UVA is to continue in our experiments. We selected the Polka because, as you can see, it's the most, the one producing a higher biomass. Red because it's the more homogeneous one producing a higher total alkaloid concentration comparing to the other ones. And then Sunstorm apricot, of course, because it was the one producing a higher amount of anti-cancer alkaloids. And it's the one that we have a genetic mapping already from the plant. So then, proceeding with these 3, we wanted to check upon the light spectrum that we are giving during the day, so dichromatic or polychromatic. And from these, we can already see that there isn't a difference if we applied a poly or dichromatic light spectrum. The only impact that we have is cultivar dependent, and Sunstorm apricot is producing less biomass, but this is a genetical trait of this cultivar specifically, so it's not dependent at all on the light. However, if we look on the anhydrovinblastine, which is one of the precursors of the vinblastine production, we can see that there is a significant increase when we apply the UV, so 55% more being produced when the UV is applied at the end of polychromatic spectrum, and it also has a tendency of increasing in 36% when the UV is applied at the end of the dichromatic day. So this is quite exciting news, at least for me. And with this, we could also see that for the vinblastine, so one of the anti-cancer alkaloids, we also have on average a 38% increase when we apply the UV compared to the treatments that doesn't have a UV applied at the end of the day. So since the UV is a good thing to keep on with, we try to see different intensities of UV, so from 2 hours till 6 hours, again, keeping the same 3 cultivars that we have selected in the first experiment. And from these, we cannot see like a same response between the cultivars. So actually, Sunstorm apricot is decreasing here the total dry matter when we apply more and more UVA, but it is cultivar dependent, the response, because Polka, as you can see, it seems that has a more positive impact when you increase. So yeah, it doesn't have a specific answer from the biomass. If we look into the total alkaloid concentration, there is the core head is a highlight here. So we can see that under 4 hours or 6 hours, it seems that it's producing more alkaloids. And if we look into the anti-cancer alkaloids, we can see an increase of 229% of the core head under 4 hours. This was like a super trooper a treatment that we could achieve here in this cultivar comparing to all of the other cultivars. So then with the start of the SNAP, we wanted to see what will be the difference if we apply the same intensity, what will be the difference if we apply it in the final 5 days, UVA or UVC. And again, the same cultivars. And what we saw is that actually the light that we were, the intensity that we were applying on the UVC was too much for the plant. So we had a decrease on the total biomass of 58%. So this is a lot. The plant was actually suffering. And on the total alkaloid concentration, we cannot see a significant difference, but actually we can see that red and polka are having a best behavior comparing to the Sandstorm apricot. However, in opposition to the total dry matter, we can see that we have an increase of 125% on the anti-cancer alkaloids being produced per plant if we apply the UVC at this rate. But the plant was already suffering a lot, so it has already a lot of sunburns. So what we wanted to do is actually, okay, we will focus then on the UVC intensity, but we will seek for another type of intensity because that was too much. So we checked then 30 minutes, 60 minutes, and 90 minutes at the end of the day, the same cultivars. And again, here we don't have an impact on the total biomass, so it's already good enough. So we are not stressing the plant that much, so it doesn't reduce that much of the biomass. And we just have an impact of the cultivar. Here again, Sandstorm apricot being the less productive. If we look on the, because we couldn't have yet the results for the alkaloids for this last experiment. This was the last one that we did, so we don't have the results yet, but we have some physiological results like photosynthetical rate, which we can see that it was decreased into 21%. So the plant somehow was suffering. And also we can see that on the specific leaf area, we also have a decrease in 14%. This means that the plant is producing thicker leaves comparing to the other treatments and cultivars. So in conclusion, we can say that just 2 hours of UVA is already enough to induce a higher anti-cancer alkaloid production. There is no notorious difference between polychromatic or a dichromatic light spectrum during the day. We know that the 10 kilojoules per square meter was too much, so it had a negative impact on the plant biomass comparing to the other treatments. However, we increased a lot the anti-cancer alkaloid production, so it was 2.25 times fold higher comparing to the other ones. So we really needed to study further the UVC. On the morphology level, we can see that the plant is getting thicker leaves with the UVC and that it is decreasing the photosynthetical rate. So now we really need to look into the alkaloids and see what is happening there. And also we are starting to look on the enzymatic production, so on the enzymatic pathways of the plant, so we can see what is also happening on the plant. And like my last conclusion and the key factor is that actually red with the 4 hours of UVA at the end of the day was like one of our star combinations, and we are really glad that we attained this one, but still we need to look into the results of our last experiment. I thank you so much for listening, and I'm also open to answer your questions now. I don't know if perhaps I speak it too fast, but I don't know about the time that I had, so I had to.
No, it's good. Thank you.
Thank you, Larissa. Any questions?
I have.
Yes, good.
And one, it could be very stupid question, but so this, I don't know if.
Larissa, can you hear?
Listen?
Yes, I hear you like far, far, far away.
I'll
Microphone is
speak
there.
more louder. So the question is, does it make sense or not and to when you apply this UVC and UVA, so not in a continuous way, but let's say 5 minutes, then you shut down, then another 5 minutes, so periodically small.
He asked if
periods of
you
time.
try to apply UV light treatments in pulses instead of continuous treatment. You apply interrupted treatment like a periodic
Okay.
interrupted small.
Yes, I understand. But the thing is,
It will be interesting.
yes,
Yeah.
it's interesting, but I think it won't have a higher impact than on the plant because first thing, if you switch on and switch off a light, the impulse for switch on a light, it's the part that you expend more energy on. So if you are like switching on, switching off, you are already losing more, you are wasting more energy already on that. And then if the plant can perceive a more continuous time, so not just 5 minutes, but like 30 minutes as I did, if the plant can have that, and it has already a good impact on the production of alkaloids, at least that's what we are interested in on the plant, why doing 5 minutes and then off and then 5 minutes and then off? You see, if it's working already with the 30 minutes by itself per day, the last 5 days, I think it's already good enough, you see, because I think if you just apply 5 minutes and then that's it, it's too short for the plant. I think the plant won't perceive it as a stress, just 5 minutes, you know.
Enough duration to make stress for the plant.
So I can add something. I think it's a good question. Actually, I think it's a good question because in terms of, that's what we call dynamic, right? Dynamic effects. And but normally what I would say is normally when you start to characterize the systems, you start with continuous because you still don't know what happens. And then that's normally the next step. I agree with Marisa, like if you wouldn't have any effects or if you would have an impact on the plants because the continuous could make that the plants would be too aggressive, would be too damaged, then could be a good idea perhaps to switching on and switching off to try to mimic stress, but not being continuous could be that it will have a less impact on the biomass production, for instance. But we don't know, and I agree with Marisa that from the energetic point of view, this continuous is better. But well, so that's it. I'll just control it. But
So more questions?
there's no questions there, no? Right.
No.
I think not. Okay, so now we move to the last speaker of the
Thank you,
morning.
Marisa.
Thank you.
Which is I know who he is. Luís Cunha, and we'll be talking about the impact of the technology disclosure on consumer perception of horticultural products, plant factories versus vertical horticulture.
This one?
Thank you, Susanna. So, Marisa, you must be breathless for sure. So I'll try to slow down a little bit.
Yes.
I cannot go at the same place, I must confess. Okay, let's check this. Yeah, because this work? Yes. Yes. No, just checking. Yeah. Okay, so now for the last presentation, we are going to talk about the consumer's outlook towards this alternative system to the production of fresh horticultural produce. And in this case, we wanted to see how we can increase the acceptability of this product. So I'm not going, I think I will skip this slide introducing the vertical horticultural system. We have already spent the morning talking about this, but from the consumer point of view, already we can see that there are at least two ways of describing this technology. We can talk about plant factories on a more technical term, or we can talk about vertical horticulture, which is also still technical term, but probably more appropriate. So one of the things that we should take into consideration when going into the consumer perception is that food choice, it's a very complex and intricate process. So it will be influenced, well, not only by the individual and the characteristics of that individual, but also by, well, by the properties of the foods they are buying and consuming, by the environment, by society, and many different interrelated concepts. And in the particular case of the promotion of horticultural products, we well know that this has a very positive impact on health, the consumption of these products. And when we talk about the vertical systems, we know that these have a positive impact on sustainability. Okay? Particularly nowadays that, you know, most of the population lives in big cities, so away from the production systems. So if we want to reduce this footprint, if we want to do local production, so we have to look for these solutions that may be implemented in the cities. We see, for instance, nowadays in Paris, in the banlieue, so in the outskirts of the city, they are using the basements to implement these plant factories. Okay? So very local production. So taking into consideration this positive outlook and how this can impact on the consumer's food choice, so we wanted to see if somehow the way we describe the technology may have an impact on these on the attitudes toward these products, and of course on the acceptance, on the willingness to consume those products. So our main goals for this task was first to see how consumers perceive these two different designations, and if this can impact on the acceptance. We also wanted to see if disclosing information to the consumer on the advantages of these systems, if this may help consumers understand the technology, and if that may increase their acceptability. Okay? And in general, we also wanted to evaluate the consumer willingness to consume these fresh products. And in this case, we use as a model products lettuce. Okay, so because almost every consumer consumes it, it's very widespread, it's well known. So no bias being introduced by having a product that is not known. Okay, so we use this was a research by questionnaire. The questionnaire had different sections. The first one where we had a 3-word association. So we're just asking people, tell us what comes to your mind when you think about vertical farming or vertical horticulture or plant factories. So we had a random allocation. Half of the participants replied to the questionnaire regarding one technology or one designation of the technology, and the other half the other designation. Okay, so we asked what comes to their mind, and if those concepts they consider to be positive, negative, or neutral. Okay, and then we asked a set of questions regarding different attitudes related to lettuce produced in conventional system and in that particular vertical production system. Okay, and we had also a few more questions regarding familiarity with the concept and also some sociodemographics. Okay, so we had over 700 participants. Only half of them went through the word association process. So typically this conceptual process is very difficult to have participants answering. So sometimes we have as low as only 10% response rate, because people struggle when we ask them what's in your mind about this or that process. And if they are not very familiar with that process, sometimes they struggle to do it. So is typical. Anyhow, we managed to go through over 200 participants that fully answered the questionnaire. Okay, this was 200 was our minimum limit, so we were quite comfortable with this. And we can see from the statistics that from the random allocation, the two subsamples are approximately, they have approximately the same sociodemographic profile, okay, which is good. So we are not introducing any bias from this process. Okay, so going into the word association, so the conceptualization, we can already see from here that vertical horticulture generates a much more positive concept and outlook, and with over 70% of positive terms associated with the system, and only 4% of negative terms. So roughly every participant answered up to 3 words. Okay, while for plant factories, only roughly half of the participants or half of the words are considered positive, and we have already up to 14% of negative words. So going a little bit more into detail, we can see that for the vertical horticulture, we see associations with the products themselves and with sustainability, while for the concept of plant factories, we are getting aspects related to environment, but also a perception of artificiality. Okay, so here we can see this quite somehow negative outlook from this designation of the technology. So, and when we compare the willingness to consume the different products that come from these systems, if we compare first with the willingness to consume the fresh vegetables coming from the conventional agriculture, we can see that for vertical horticulture, there's no significant difference on the acceptance of the two systems, while for the plant factory, if considering produce from the plant factory, there's already a decrease on the willingness, a significant decrease on the willingness to consume. And also, this is significant difference from one system to the other. And in general, we can see that for already the perception of the different vertical farming systems, we see that vertical horticulture is more associated to being a better bet for the future. It will contribute to fresh local vegetables and also will contribute more to sustainability. Okay? In terms of familiarity, we can see also there's somehow a difference. Participants, in general, they are not well familiar with the terms, although they tend to consider that vertical horticulture is a more familiar term than plant factory. And also, when we go into the attitudes towards the different production systems, and in this case, for lettuce, so it's specific for lettuce. And what we see here, this is quite complex graph, but consider that the central line is similar to conventional system, okay? So for the vertical horticulture, we see that it's significantly considered as being without additives when compared with the conventional. It's considered as being, well, more difficult to reach, of course. But it's also considered, this is quite positive, more nourishing than from the conventional products, more hygienic, of higher quality. Well, the downfall is it's more expensive, of course, as expected. It's unique and modern. Well, it's here not very interesting. They consider it having a more unpleasant taste than the traditional ones, but at the same time, it is stimulant and environmentally friendly. So in general, we see a very positive outlook, even when compared with the conventional systems. For the plant factory, it's quite the opposite. We see it's considered as having additives, not helping local production. So it fails to address this issue. It's also hardly available, but poor in nutrients, still hygienic, that's good, but processed, inconvenient, expensive, and harmful to health. So here people consider, when we talk about plant factories, that we're really, let's say, tinkering with the process. It's very artificial, so the industry must be doing something bad. So really that have a negative impact on the consumer. Even they consider it does not respect the environment, so it totally fails the objective, and again, very artificial. Okay? And on the willingness, so let's say this was before disclosing the details of what's conveyed with the term vertical horticulture or plant factories. Okay, so what we've done by the middle of the questionnaire, we said, okay, this is the system, this is quite sustainable. Actually, we are reducing the water spent, we are reducing the number of chemical products or pesticides and so on that we are using. So we are increasing productivity. It can be local, so we reduce the ecological footprint. So after disclaiming this, we went to compare and see if this was affecting the attitude towards these products. So it's quite interesting that we see that this disclosure has already an impact on the participants, on the way they perceive even conventional horticultural. So you can see that when comparing for the conventional before and after disclosure, there's a reduction on the way the conventional production is perceived. Okay? Because we are informing the participants that these systems really have a positive benefit when compared with conventional horticulture. Okay? When comparing the different designations of the technology, okay, we see there's always a huge increase on the place factory. So now people understand that after all, it's not that bad. Okay, but still, their willingness to consume and their attitudes are significantly lower than the ones that we obtain for the vertical horticultural system. Okay, so in this case, it is clear that designation of vertical horticulture immediately generates a much more positive outlook, while plant factories tend to generate a negative perception. Even we can see that may increase the perceived risk associated with the technology. So it has an inherent decrease on the willingness to buy the product and consume the product. So definitely from our research, we can see that when disclosing the technology, when using these, for instance, on the labeling of the products as a way to promote this system as a more sustainable option, then definitely the designation of vertical horticulture will be the one of choice. Okay, and that's it. Thank you for your time. Do you have any questions?
Any questions from the audience?
Yeah, maybe.
There is one there. Perhaps you can start, Miguel, and then you can.
I would like to know if in that characterization of the respondents,
yes,
if it also you addressed the origin from the respondent, either if the person comes from a rural area or a big city or a small city, and probably it would be interesting also to check whether this origin also influences the type of response.
Yes, that was a variable in our questionnaire when we do the socio-demographics. We asked the participants for their self-awareness if they live on a rural or on an urban area, in a scale. So they give us that perception. I don't know the figures by heart, but I believe that 95 to 99% are from urban background. So it has to be also with the way that we promoted the questionnaire. Because if we had a larger sample, or if we wanted to do that comparison, so in this case, it was not our objective to compare these different areas. But I believe that our objective was met because the focus of our research was mainly urban population, because that's where we will be implementing, or it's foreseen to be implemented, this type of production systems. Otherwise, you lose the benefit of being local. Yeah. Okay, so I think yes, we have been there.
Is there a gender, so female, male difference or no?
In terms, we have roughly, we can go back, I think, 2/3 female, 1/3 male. I can tell you that for this type of, let's say, randomly dispersion of the questionnaires through social media, we had a quite high male level of male respondents, because normally you can get up to 80% female if we do not direct the system. So there's a good representation there.
But are the results different if you separate from them?
If we
One factory, I guess, is more, I don't know, but it seems to be less positive for female outside. I'm just wondering.
We didn't went yet into those fine details, because the data is the full data is relatively new. But from what I have from my mind, there may be some differences, but still the vertical horticulture will be one of choice all over the different socio-demographic groups. Okay.
Yeah.
So there is one question online.
Negative.
Last
Yeah.
Yes, probably this may have an output. Yes.
Can you please read?
So the question is, has LCA, so life cycle assessment, a role in communicating sustainability to consumers? And how about product environment footprints expected to be mandatory from 2024 onwards? So yeah, I would say that may have an impact. Of course, that will depend also if consumers are more sensitive to sustainability issues. That's something we didn't plug into the presentation, but in the questionnaire, we have a sustainable sensitivity scale. So we may further on compare if how much this is impacting on the way the technology is perceived. But yes, in general, this information may have a positive outlook. Although I can tell you from our experience on the way the consumer perceives technology, and even on the information that it's presented on the label, if it's not presented in a very simple and straightforward way, this becomes confusing to the consumer. We have that experience already with the nutritional labeling, and we all have experienced those daily recommended values for fats and for sugars and so on, that many times if we try to control our diets, it's very difficult to work with those numbers. And by opposite, when we see the more nowadays usual, the Nutri-Score, where we just have like these color codes, it's very easy for the consumer to decide upon this color scheme. There may be some bias on the system, but it helps a lot consumer to do this choice. So in this case, the information on the life cycle, on the footprint, it may help if we get a clear way to communicate this to consumer.
Perhaps
your questionnaire was spread on in Portugal or
This is national, but mainly focused on Greater Porto area in this case.
Perhaps I will show you the way that in Denmark, because this is the biggest European plant factory,
Uh-huh.
how they are displaying and how they are communicating to the consumers.
Ah,
I have it.
Yes.
Is that one? It is 05 Machado. Yes, that one. Because I just passed very quickly, but it was.
And I can tell you that Denmark is quite a particular market because they are countries you
I know, no, like
highest consumption
it's not in this one. It's that I will
organic
open.
products.
In the folder.
It's in the folder.
They really, actually, I think nowadays they can only sell organic products. They cannot use conventional
I
production.
can already share
Yeah, here.
here.
Yeah, open. And
Ah,
select it.
okay, just this one. Okay. Perhaps I can share here
Yeah, we can see the
because then you can see.
other one.
Not here. That's how they are how they are harvested. And here you can see the way that is displayed. Is in a, and it what is funny because this is in Danish, but you see here that is mentioned environmentally friendly. So they make different symbols. This is really the layout how it goes to the consumer. Environmentally friendly, free of pesticides, recycling.
Packaging.
Well,
It was not.
yeah, here.
And here it's funny because it says that it's producing vertical farm. The word vertical farm is used. So it's a scheme of vertical farm. So they communicate the word farm. Vertical and like vertical farm, yes.
So
And farm. So not factory, and not vertical horticulture. So that's the way they also.
In this case, not only they convey the major advantages of the system, the benefits, but also the system itself. But on the
Production system. Yes. It's not very common. I can say that, for instance, in some discussions that I have been in different panels and other workshops and seminars about this topic, the Americans they tend not to put the production system, and they are also big players in this sort of production in plant factories. And what they say is that they claim about health, especially about that this salad it has a higher nutritional value, something like that. So putting the focus on the product itself and not on the production system.
But then that's also because the way American consumers perceive the products is quite different, and
Yes.
the way the dynamics of the market is quite different.
I think it's very interesting because, for instance, if you see, because vertical farms, they have started in Asia and in Japan. And I think for people that know how Japanese are, they are really totally fan of food. They have no problems with artificial systems and they love hygiene and so on. So for them communicating that it's a plant factory, it will be rather actually a positive thing. So this is really very much depending on the culture.
Because
Yes.
here we see factories associated to pollution.
Yes, and it was interesting to see for the Portuguese.
But you know, Japanese they generate they created the zero defect system. So when you talk about factories, you talk about zero defect and totally controlling
Yes.
the system. So it's also quite a different outcome.
Okay.
So I have one question. Sorry.
Go ahead.
In the questionnaire, did you consider characteristics that have a trade-off between them? For example, if you have a high quality product, you have a high cost, high price. If you have low quality, you have low price. And the user, the people can choose between one of them, like how much quality versus price they want.
No, if you manage to go back to the presentation.
That's challenging. Perhaps it's still open.
Yes. So
yeah, you can see here we have asked in terms of the attitudes towards those different aspects. So you can see this is the exact slide you had before.
Yes.
Yeah, here you can see, for instance, we talk about how the price is perceived.
Yeah, but
so
for example, this with respect to this.
No, we didn't. We did not perform the choice experiment. So
yes.
In the Soil for Heart project, we have done a choice experiment where we can present the product with different options. That can be the following step for the research.
Yes, because what I've noticed is people still consume sometimes even bad products because they are cheap.
Yeah.
For example, they are still consuming mechanically separated meats, which is very bad, and they do it because it's cheaper.
Yeah.
And this choice of you want something cheap or you want something with quality,
I can tell you
expensive.
without doing any research. And
Yes.
from the market knowledge, in Portugal, we know that Portuguese consumers buy over 50% of their products in price with price promotions. Okay, so as the buying power is very low in Portugal, price is the main driver of choice.
Okay.
We had in previous years, we've done work on food choice criteria. We knew the sensory profile was the first factor on food choice, but for the last decade, now it's price due to the low purchasing power of Portuguese consumers. That said, we know that there are some market niche that will have a higher purchasing power and they are willing to pay more for these fresher and greener, more sustainable products. In general, the consumer is not willing to pay more for the sustainability. So if you have the conventional one and the more sustainable, if they are at the same price, they will buy the more sustainable. If it is with a more expensive, then probably they will not buy it unless they have a high purchasing power, or if they have a lifestyle that goes with a high purchasing power many times, that they want to show that they are buying the more expensive.
So it depends too much on the economic situation of,
definitely.
Of the consumer.
But in general, the majority of the consumers, they will choose the sustainable one if they don't have to pay more.
Yes.
Okay? And there's many examples of behavioral economics that show us that many companies have decided to go for the more sustainable product without a higher cost, and they have gained a huge market share due to that choice.
Yes. So maybe we organize these criteria from the top one, which is the price, for example, next quality, next sustainability, like organization from what is driving the purchasing.
This is confusing in this case, I recognize, but here we are not doing a ranking. We are doing the comparison with the conventional one. So this integrates several sets of questions in a single image. Okay?
Thank you very much.
Thank you.
Thank you.
So now we can have some time for general discussion. I don't know if you have some questions that you'd like to ask, that you would like to raise among all the sessions that have been happening here and among all the talks. You can ask in Portuguese or in English.
What's next?
Yeah.
In terms of what?
Next projects. Yeah.
Well, but that's not really for the audience. Well, perhaps I would like to ask your opinion, since we have been here all the morning and discussing about vertical farming. Do you believe that is the future, or estava a dizer assim, quer falar em português? Agora, no fundo, falou comigo no intervalo e tinha ali também uma outra pergunta.
São estudos que dizem que é relativamente livre de bactérias e doenças. E no caso aconteça uma pequena contaminação, como é que é controlado? Isto ser um sistema tão fechado, a contaminação deve ser mais rápida do que normal. Como é que é controlado?
Certo. Pronto, eu para responder essa questão é assim, nós aqui claramente, quando tem a ver com a parte de doenças radiculares, não é? Porque como todas as soluções nutritivas, as plantas crescem em prateleiras. E depois há diferentes sistemas. Há sistemas onde as plantas estão em sistema hidropónico, não é? Portanto, as raízes estão em contato direto com a solução nutritiva, é o mais comum, com reutilização dessa solução nutritiva. Portanto, a solução nutritiva é recolhida das prateleiras, de um modo geral fica, por causa da questão da oxigenação, porque se ela tivesse em tanques estanques, ou seja, parados, acabava por não haver oxigenação, portanto, ela é recolhida, essa solução nutritiva, para tanques gerais, e é bombeada novamente para as prateleiras, e, portanto, eles fazem normalmente ciclos de 15 em 15 minutos, em que está, enquanto há função alternativa durante 15 minutos, depois vai com os reservatórios, é bombeada. E nesse circuito pode-se fazer sistemas de desinfecção físicos, com ultravioleta, com ozono, etc. São sistemas que garantem que não há nenhuma contaminação. Portanto, mas de um modo geral, o que é que acontece? Estas fábricas de plantas, eles são extremamente cuidadosos. Por exemplo, para aceder à zona de produção, nesta aqui, eu já visitei na Holanda e visitei na Dinamarca. Esta, por exemplo, na Dinamarca, como é uma fábrica muito grande, para aceder, não é qualquer pessoa que pode aceder, não é? E as pessoas que acedem têm que fazer desinfecção das mãos, obviamente usar touca, máscara, e passam por um túnel onde são também desinfetadas. Têm que levar uma bata e passam por um túnel onde são desinfetadas. Portanto, quando se vai para a zona de produção, já se vai totalmente tapado e desinfetado. Depois, temos que garantir que a material biológico, neste caso as plantas que lá estão, não têm contaminações. Como é que se garante isso? Semente certificado, ok? Em que é adquirida a semente chega lá e na própria fábrica há uma zona onde eles fazem a sementeira. E podem fazer uma pequena desinfecção da semente, com hipoclorito de sódio, tanto com lexívia ou com água, fazem uma desinfecção, fazem isso e eles fazem isso para ter a certeza, porque eles são completamente, entre aspas, paranoicos, porque efetivamente se houver um foco de doença, até pelo sistema que eles têm, que são tão altos, com as 14 prateleiras, e o facto de só irem ver as plantas 3 vezes num ciclo cultural, acho que isto é importante, nós pensamos sobre isto, não é? E que isto é mesmo um ato de fé. Nós pomos as plantas a germinar, estão lá nas prateleiras e nós, olha, por isso são 3 vezes no ciclo cultural e vamos lá espreitar, ver se está tudo bem. Um produtor passa sempre pela sua cultura, ou então tem, não é, se for ao ar livre, agora até com as tecnologias de satélite, etc., a imagem se consegue ver com o NDVI, se o planta está em stress. Aqui estamos a falar em sistemas em que, obviamente, se pode vir a colocar câmaras e poder ter esse controle, mas isso ainda aumenta mais o investimento. Portanto, eles querem ter a certeza absoluta que os riscos são rapidamente zero. Então, desinfetam a semente e é tudo feito lá. Portanto, não há, ao contrário de outros sistemas de produção, por exemplo, numa estufa que se pode comprar plantas já germinadas, plantinha, não é? Em mote, ali não, entra só a semente, é germinada lá, tem câmaras de germinação também. Portanto, são feitas câmaras de germinação onde a temperatura é ótima para a germinação, com os tabuleiros todos encaixados uns em cima dos outros, porque é no escuro, e a partir do momento que começou a germinação, vai para ali, para as verticais, para a luz e para começar a produção. Um aspecto que eu achei também interessante, que posso também partilhar, é que nós pensamos sempre que isto é pouco label intensive e realmente não é preciso muita gente, mas eles dizem que ainda assim ainda são precisas, porque fazem lá as sementeiras, fazem a colheita diária, o embalamento, é tudo feito lá. Neste, em particular. Vi, por exemplo, aqui eu vi também na Holanda, era uma tipologia diferente. Na Holanda eles faziam microverdes, não é? Ok, portanto este era o tal baby leaf, que são um bocadinho maiores, os culturais são maiores. Nos microverdes, o que é que eles faziam? Usavam tapetes de germinação, eles chamam de tapetes, é tipo, é uma malha quase, não está, ela é mantida umedecida e como o microverde é muito mais pequenino e fica muito menos tempo, não precisa tantos nutrientes e tanta solução nutritiva. Então germina e eles depois recolhem aqueles, puxam quase aqueles tapetes, cá para fora, e são cortados e preparadas as embalagens, mas ali, como eles trabalham para grandes chefes de Amsterdão e arredores da Holanda, preparam mesmo para aquele chefe aquela encomenda, posta na caixa que vai ser entregue. Portanto, é uma entrega muito local, muito de proximidade. Também acho que é uma opção interessante. Enquanto que estes vendem para supermercados, para grandes superfícies.
Isso é mesmo fácil.
Já é uma escala diferente, é mesmo de farm. É mesmo de fábrica.
Portanto, no fundo não se coloca a questão de fazer um tratamento das plantas, de evitar...
Exatamente, é mesmo isso, sim, obrigada, é mesmo isso. Portanto, no fundo, o tratamento é só a desinfecção da semente e, obviamente, pode surgir qualquer foco. É altamente improvável com todos estes cuidados. Mas, efetivamente, sentar-se uma praga lá, eu não digo que seja por ser um ambiente fechado que é difícil, porque um ambiente fechado até é mais fácil de controlar, com um ambiente aberto, pode ser mais fácil. O problema é que não há uma vigilância tão próxima das plantas, pode estar a haver um foco e estar a perder-se esse foco da doença ou da praga.
I don't know if I understood very well, but the question was
Probably not.
was about
the diseases, the risk of diseases.
They spread very fast in indoor environments.
They can, yes, they can do that.
I think this is one of the biggest problems, especially in microgreens. There is mold problems that spread very fast inside within the microgreens. Actually, there is still work to be done in this side of the indoor production process, because environment should be managed in a way that these diseases don't spread. The environment is good for the plants, but not very humid, not very hot for the spread of molds, for example. And the aeration, it should be very good. So there is still work on the design of the shape of the plant factory, shape of air vents, shape of how the air should flow to avoid this kind of infection, to give good aeration. So there is a lot of work to do there.
That's definitely one of the main points that has been raised in several factories, is the point of ventilation. Portanto, garantir uma boa ventilação nas prateleiras e homogénea. It's really critical. But in principle, it's like what we were saying, and there is no very high risk of contamination. And the idea is, if you start applying pesticides or something, then you are really perverting the system, because the idea is that these systems are pesticides free. É resíduo zero. Portanto, se não for nessa política, portanto, é mesmo tentar reduzir a aplicação ao máximo. E então é melhor fazer de uma forma preventiva, não é? Com estes cuidados, não trazer planta de viveiro já plantinha, pode trazer qualquer coisa, e desinfetar a solução nutritiva, e à partida não corre mal, não há razões para correr mal.
Eu tinha uma pergunta também, que era relativamente à injeção direta do célula das plantas, sabe? Todo totalmente produtivo.
É assim, a injeção nas fábricas de plantas não é muito comum. Em estufas é muito comum, porque nas estufas normalmente faz aquecimento, principalmente na Europa do Norte. É feito o aquecimento com caldeiras, não é? Porque eles usam o gás natural para o aquecimento da estufa, não é? Porque não se consegue produzir ao longo do ano todo se não houver aquecimento da estufa. E como eles produzem all year round, é mesmo os 12 meses do ano, aquecem. E como usam gás natural para o aquecimento, o subproduto vai ser o dióxido de carbono, que é limpo, ao contrário de nós em Portugal, por exemplo, queimamos, pode ser, sei lá, biomassa, qualquer tipo de biomassa em que não é limpo, não é? Depois o dióxido de carbono que é emitido, os gases que são emitidos não são limpos, têm substâncias tóxicas que não podem ser injetadas na estufa. Lá, como fazem com dióxido de carbono, com gás natural, pode ser injetado, e é super comum injetar. Todos os produtores fazem isso, só que porque fazem o aquecimento com boilers, portanto com grandes caldeiras, e assim, as áreas das estufas são muito superiores, por um lado. Por outro lado, a inércia térmica de uma estufa, as estufas perdem muito mais calor, é muito mais difícil manter 20 graus numa estufa do que manter uma fábrica de plantas. Essa é uma grande vantagem das fábricas de plantas, é que o isolamento é muito maior, não é? E, portanto, isso é uma vantagem. E países, por exemplo, países do Médio Oriente, países em que as condições climáticas são extremas, por exemplo, a própria Noruega, que produz também estufas, estes sistemas são, eu não direi que para Portugal sejam a solução ou o caminho, sim, quando eu às vezes até costumo perguntar se é o futuro, eu digo, já é o presente. Se quem está dentro desta área, se pesquisar, já existem praticamente todos os países que estão a produzir, já existem mesmo muitas unidades de produção pelo mundo fora. Agora tem investimentos elevados, definitivamente é o ponto crítico, é o investimento inicial.
Ou compra terra ou faz uma fábrica.
Como?
Ou compra terra ou faz uma fábrica.
I would like to add two things that I consider also important as advantages of these systems, which are the fact that because they are installed in the city environment, they don't add the disturbance to the landscape, as it happens, for example, with the plastic greenhouses, and which also is not well seen by the general public. And also in agreement with the thing of introducing CO2, is that also this protected environment can also have the potential to improve the environmental performance of other industries, as a way to install systems, as it already happened in the Netherlands, where they install a system to collect byproduct CO2 from other factories to inject in the greenhouse industry. So because vertical farms are installed in the big cities and in industrial areas, it would also maybe facilitate the use of CO2 produced by other industries to be utilized in fertilizing the plants in this kind of production systems.
Yes, I would say if the CO2 is available and if the CO2 is clean and available, is definitely an extra, because you are controlling the rest of the conditions. You are controlling temperature, you are controlling light. So it's like the idea that we say a label minimum. So you give all the, so the limiting thing would be CO2, because you are really controlling the other. So if you are able to inject CO2, definitely you are giving all the conditions, the best conditions for the best performance of the plants. Mais alguma pergunta? Não?
Well, in respect to the last presentation from Professor Luis, I would also think that it would be important to check whether the people are perceiving correctly what means vertical horticulture versus plant factory, because there are, I think that I also prefer, of course, the term horticulture, vertical horticulture, but maybe people are confounding. I think it's a term that which also is more broad, so it gives margin to people to think about, for example, rooftop production or production in walls. So I'm not very sure if also the people are quite acquainted about.
No, they are not. Yes.
If they are thinking in the same.
No, they are not. But the thing is, you have to think that I'm answering, but then the thing is that if you will take, the point is, if you take now currently to the market the product that you are labeling, saying plant factory or vertical farm, that's what happens in Denmark and in many other countries. If they put you have to find out how the consumer is perceiving this, because you are not first training people, informing, and then putting the product. So that's a normal thing. So what you want to make sure is that people that are not, how are they perceiving a word just by the name without having no idea about the concept, or perhaps some they have. And that's why in the questionnaire, there was the first part where you are asking which words come to your heads when you think about these systems. And that you could see that for plant factories, they have very often words that were not positive attributes. And then you see when you inform what it means, like Luis was explaining, there is a part of the questionnaire that you really, and you are not telling them like, this is much better. No, you are just informing the concepts, showing the photo and saying this system is characterized by this, this, and this. And that's the way you describe, you characterize. And then you ask again the questions, which words come to your head now that you are informed. And you see that the characterization changes. And Please.
At the beginning, yes, informing, we are just evaluating the willingness to try and we compare. Before disclosing the aspects of the technology, we ask their willingness to use the product, and we ask afterwards. So we see there's an increase when this information exists. But at the beginning, in the mind of the participants, that's what we get for the word experiment, that really there's a misconcept. Okay. How can we overcome this? With communication. How much it costs? Millions. Okay. So we all, I think you remember in Portugal a few years ago, Optimus disappeared from the market. Yes, and from Optimus we got not. Okay. How did they manage to maintain the same recognition level for the new brand? They invested hundreds of millions of euros in communication. The new brand was everywhere. In television, in radio, even in the rectory of the University of Porto, you have a big, board with the new brand. So you impregnated the mind of the consumers with that brand, and within a few days or weeks, it was already well known. We cannot do this to promote the plant factories or to promote vertical. So we really have to know how the consumer will react to this information disclosure, saying, okay, we have something different here. And how do you perceive this as being more risky, or you perceive this as being healthier and more sustainable? Well, that's the simple thing of this research. And clearly, vertical agriculture is the way, and we see the Danish are also going that way. So, that's something to
Although they are calling it farm, but farm still is not the same as a factory. It's a different thing.
It's still natural. It's still connected to the natural environment, to the way things are typically done. So you don't introduce artificiality effect.
And okay, so well, in that case, since this was a long morning, and I must thank and pass the word to Silvio of the Circuit for the chat.
Pronto. Agradeço a presença a todos vós que tiveram a oportunidade de vir aqui, que honraram este projeto. E é tudo. Até à próxima. E que novos projetos venham. Agora que nos conhecemos, estes grupos, acho que está semente lançada, já com alguns grupos.
Não era terra.
E nem sequer é. Muito obrigado a todos.
So we finish. Thank you very much. We are going to finish this meeting. And
Nós estamos a